experimental proof of analytical and experimental proof of concept demonstrated in lab. Means actual experimental process and analytical process in this third TRL. Then next phase is development phase, that is prototype and validation, in which fourth TRL consists component and system validated in lab environment, in which we fabricate the device, and in fifth TRL component and system validated in a relevant environment. Then scaled up prototype means, for example, in energy storage devices, we will optimize the different temperature and humidity and other conditions to check the performance of that device. And in sixth TRL, system model or prototype demonstrated in operational environment means actual working environment. We will check that fabricated device or then last phase is development phase, that is integration and commercialization, which includes TRL 7, that is system prototype demonstrated in actual operational environment, then actual system completed and qualified to the test and demonstration. Then ninth TRL actual system proven in optional development, that is market ready product. Then what is the importance of a TRL scaling for translating ideas to market ready technologies? Firstly, TRL scaling is, as we know, the TRL is important to transfer our idea, research idea, into the commercially available products. It ensures that a systematic progress through the technology, lifestyle, addressing technical, ecological, and operational challenges at each stage. We can optimize the conditions, and we can know that what is the problem during the its actual market ready device fabrications. Here, why it is critical? That is the structural development pathway, clear milestone. TRL provides a roadmap with defined stages, making it easier to track progress and identify the gaps. Then we can make the focused on specific goals or specific achievements. We can avoid the unnecessary delays. Then risk, we can know the risk. What are the risks in fabrications? What are the to avoid unnecessary delays? Ensure that the fundamental research transition into the validated prototype with the minimal risk. Early detection of failures are useful to resolve lower TRL levels, preventing costly setbacks during the later stages. Then alignment with the stakeholders. Communication tools. TRL serves as a common language for researchers, engineers, and investors and policymakers, which can be useful to understand to transfer the our research from lab to the commercial ready product. It is important to the people which are working at every stage understand the our research, what are the process going through. So this is one of the linking between the all the researchers, engineers, and investors to make our idea to the market ready application or devices. Then confidence building, demonstrating the progress along the TRL scale can install the confidence in the stakeholders and attract the supports. Means the output or means by showing our output or research progress, we can attract lots of funding and give the confidence to the government or agency to the invest in our research idea for getting further funding. Efficient resource allocation, targeted investment, like resources are directed towards the technologies that demonstrate the readiness to advance, ensuring efficient use of funding. Then prioritization helps identify the high potential technology, allocate the resources where they are most needed. Then finally, it is the bridge between the value of that is a gap between lab scale innovations into the commercial development. Then enabling the scale up. So TRL scaling emphasizes intermediate steps like prototyping, pilot testing, and validation, helping bridge this gap, enhancing the market readiness. Commercial viability: by validating the technology performance, scalability, and cost effectiveness, trial scaling ensures that the technology meets market demands, compliance, and standard. The ensures technology adheres the regulatory, safety, and industry standards. Also attract the funding and partnership, investor confidence. It is useful to build their confidence on our research. Demonstrating progress to the TRL levels shows the potential investor that the technology is useful and which can be used in market. Collaborative opportunities, which this can provide the companies, research institutes, and governments are more likely to collaborate with the TRL scaling, is well documented. Also, driving innovation to the impact, accelerating commercialization. A structured TRL process helps speed up journey from idea to real world application. Social and environmental benefits for critical areas like energy storage. TRL scaling ensures timely delivery of impactful technology, address the global challenges like energy sustainability. So my targeted area is energy storages, and in that particularly supercapacitor. So today I will show that how TRL work in case of energy storages. Firstly, what is the need of energy storage? As we know that the increasing reliance on renewable energy sources like solar and wind, renewable energy intermediate, it is the renewable energy is not a continuous. We can not use the, there is supply of renewable energy is limited, so we have to find some solution which can be provide as provide the more options to store the energy and useful for the further applications. And also another goal is the decarbonization, that is reducing the greenhouse emission by enabling the large scale renewable integration, supports the electrification of transportation and industrial sectors. There are lots of challenges between the energy storage system, that is mismatch between the energy generation and consumption, need for load leveling and peak saving and grid stabilization. And there are key requirements for energy storages are high energy density, long cycle life, faster charging and discharging rates, and scalability and cost effectiveness. And the application of energy storage are mainly where renewable energy storage devices energy is used, portable devices like regular use laptops, for smartphone, and in that compact and efficient power sources, electrical vehicles demanding faster charging and high capacity energy storage solutions. In energy storage includes mainly the battery, fuel cells, and supercapacitors, in which energy storage devices technology are the system which capture the energy in various form and it release when it is needed. They play crucial role in balancing energy supply and demand, improving the energy efficiency, and enabling the integration of renewable energy sources. Provide power during the outage, and means whenever the for example if it is provide the power during the outage or period of a high demand, then balance energy generation and consumption over time, store intermediate energy from sources like solar and wind, and enables the energy use in portable electronics and upgrade systems. In the study of energy storage devices, the electrochemical energy storage devices are important, and in that Regan plot is one of the important factor which can shows that the energy density and power density. Depending on that, we can see the position of a supercapacitor. It is between the batteries and commercial capacitor. That is, the supercapacitor are the bending gap between the commercially available capacitors and batteries. So what are the electrochemical storage devices? These are the system that store the energy in the form of chemical potential, and it release in the by using the electrochemical reactions. They are widely used due to the versatile scalability and efficiency in various application. Ranges from the like portable electronics. Then another important energy storage device is batteries, which having the high energy density, stores large amount of energy for long durations and moderate power density, and not ideal for rapid charge discharge. This is a limitation of battery, and limited degradation occurs due to the several thousand cycles. Means the cycle life or life cycle of battery is less than that of the supercapacitor. And also there are some environmental concerns observed for the batteries, like in lots of batteries we know that the acid electrolyte is used, which can be causing some corrosion or hazardous, and heat also having the limited time span also, lifespan also. Then my particularly concentrated area is a supercapacitor. The supercapacitor represent a new generation of electrochemical energy storage devices, which has the high capacitance and energy density compared to the ordinary capacitors. For the supercapacitors, three factors are important. That is the electrode material, electrolytes, and separators. In case of electrode material, which it should be the high surface area, porous structure, good conductivity, reversible redox, it having the reversible redox reactions, that is multiple oxidation states, and stable in electrolyte. Electrolyte, in case of electrolyte, having the wide potential window, that is aqueous, non-aqueous, and organic. There are three types of electrolyte used, and electrochemicals, also electrochemical stability, high ion concentrations, and good ionic conductivity. Separators mainly having the porous membrane, non-reactive with the electrolyte. Why supercapacitor are a game changer in a energy storage device, energy storage? Because it having some kind of a unique features like high power density, delivering rapid energy burst, ultra fast charging and discharging, long cycle life compared to the traditional batteries. Then why supercapacitor? Because it is ideal for applications requiring quick energy delivery and recharge, complementary to the battery. While batteries provide high energy density, supercapacitor excellent power density. That is, batteries having the high energy density than supercapacitor, but lower power density than the supercapacitor. While problem in case of a supercapacitor, they having the limited energy density. So research area in supercapacitor is mainly concentrated on to improve the energy density of material. So for that purpose, we have to search new materials which having the good energy density. Also, emerging opportunities in supercapacitor as renewable system, that is which can be managed the solar and wind energy. That, for example, I'm working on photocapacitor, that is in which we are use the solar energy. That is combination of two devices, that is a solar cell and supercapacitor. One is the energy harvester part, and another one is energy storage part. Another one is electrical vehicle provide in next option, that is electrical vehicle providing energy from acceleration and regenerative braking. Portable electronics, that is enhancing the performance in compact devices. Research focus areas, that increasing the mainly increasing the energy density, developing advanced material like carbon-based graphenes, nanocomposites, some hybrid composites, and mainly in supercapacitor now work is concentrated on the two-dimensional materials in xylene type of materials. There are another factor is reducing cost, exploring the scalable and eco-friendly manufacturing techniques. Now I'm using some chemical synthesis methods. So that is also used to reduce the fabrication cost, and integrating the hybrid system, that is the combining supercapacitor with batteries for optimized performance. Then comparison the performance of batteries versus supercapacitor. Here we can say that in case of voltage, mainly battery can provide 1.2 to 4.2 volt, while in case of supercapacitor it is limited potential window, that is the 1.2 to 3 volt, and energy density in case of battery is higher than the supercapacitor. In case of a power density, battery having the lower power density than that of the supercapacitor. So we main concentration is improving the energy density for a supercapacitor to uh, to fill the gap between the batteries and conventional capacitors. Then charging time in case of a battery, it is nearly 3 hours, and in case of a supercapacitor is within a second we can charge it. And discharge for battery is more, that is the 1 to 5 hour, which is again depend on the energy density. Due to high energy density, that operational potential window also increases. And in case of a supercapacitor is very less in some second or so. But in case of life cycle, we know that supercapacitor having the much better life cycle than that of the batteries. Then there are some type of supercapacitor. It's basically depend on the charging mechanism. Supercapacitor is divided into the main 3 types. Basic types are EDLC and pseudocapacitor. EDLC is electric double layer capacitors. That is a mainly uh, depend on the carbon based materials, and they are non-Faradic reactions are takes place. While in case of pseudocapacitors, the redox reactions are takes place and Faradic reactions are takes place. And it again includes the materials like conducting polymers, metal oxides. While apart from these 2 types, third type is hybrid capacitor. So overcome the drawbacks in conventional capacitors and in pseudo capacitors, this third type is generated, that is hybrid capacitors, in which we can combine the some battery material with a supercapacitive material. Therefore we can improve the energy density of a supercapacitor. So ultimately we can improve the potential window, working potential window, which can be further improve the performance of a supercapacitor, and we can achieve that our targeted performance. So based on that, there are some recently working type of composites, metal ion capacitor, redox electrolyte capacitor, battery like hybrid capacitors. So these are the basic working mechanism for supercapacitor, that is electric double layer capacitor, pseudo capacitors, and hybrid capacitor. In as seen in figure, electric double layer capacitor, here are non-Faradic reactions are takes place. That is ions are deposited on electrode, and there is no redox reaction takes place in EDLC type supercapacitor. While in case of a pseudo capacitor, redox reactions are takes place. Due to this redox reaction, the stability of material is decreased. But in case of EDLC, the stability is good, having good stability. So taking the advantages of both of these, third type, that is hybrid supercapacitor, is generated, which is the emerging type, in which we can combine the 2 materials, one from EDLC and one from pseudocapacitor. So we can overcome the drawback of these 2 types of material. These are some applications of a supercapacitor. That is mainly it is hybrid car, electric car. This is day-to-day used material, which can instruments or material which where we can use the supercapacitor. So actual in lab, actual experimental setup used for checking the supercapacitor property, we use the 2 types, that is 2 electrode systems and 3 electrode system. In case of a 3 electrode system, we use the reference electrode, counter electrode, and working electrode, and electrolyte. This is the actual photograph of a experimental setup. And mainly the fabricated thin films or devices are characterized by the using cyclic voltammetry, galvanistic charge discharge. In cyclic voltammetry, we find the operating potential window for that material, and using this formula we can calculate the specific capacitance for that particular material. After that, this is the galvanostatic charge discharge curve, and this is also another characterization to calculate the specific capacitance of that material. In that, we kept the potential window constant and check the charge discharge curve at a particular constant current density. And this is more important of characterization to know the discharge timing for that particular fabricated material. And using this formula, we can calculate the energy density, power density, and Coulombic efficiency for that material. So for here, for example, I will present one of my paper in which I fabricate the ferric cobalt at thin film, and after that characterize that one, and you already this supercapacitive property. So for that, I have fabricated this thin film using the hydrothermal techniques. These are the some chemical parameters which are used for fabrication of this thin film, in which we just take ferric nitrate and cobalt nitrate and use urea as a reagent, and for kept for 4 hours at 453 Kelvin temperature. After that fabrication, we have to confirm that fabricated material using the different characterization techniques. One of the characterization technique XRD, X-ray diffraction, that is a basic characterization technique which is used to identify the material is fabricated fabricated in that particular material or not. So from that we confirm the fabrication of that material. Another one is the XPS technique, in which we can know the oxidation state for that particular material. So here from using the XPS and XRD, we are confirmed the fabrication of our material. Another one is the SCM technique, which is used to see the surface area of that material. From this image, we can see that the surface area of that material is porous, and in earlier slide, we can see that the basic requirement for supercapacitor is the surface area of material should be the porous, and further, but actually to calculate the surface area of that material, we have to use another characterization technique, that is a weight study. So from that we can know what is the surface area for that material, and that material is useful for our study or not. Then from this characterization, we know that this material having the good surface area, so we can use that material for the supercapacitive property measurement. Further, we check the cyclic voltiogram for this material at different scan rate, ranging from 5 to 100. Then we know that after that we calculate the specific capacity using the previous formula. It is nearly 1400 specific capacitance is observed for that in lab for thin film case, and in this case we just used a 1 by 1 surface area. Also, we check the galvanistic charge discharge study. From galvanistic charge discharge study, we know that the discharge time is very less, that is 80 seconds only, but still it's showing some performance. So further, we take the EIA stability study for this material. For study the stability of this material, we have to take the number of cycles. In this case of material, we check the 5,000 cycles for that material and compare the performance for first cycle to 5,000 cycles. And after that, we calculate the capacity retention for that material. And from this figure, we can see that the capacity retention for this material is nearly about 84%. Means after 5,000 to 6,000 cycles is showing the good capacity retention. So we can use that material for device fabrication. And also another important characterization is EIS, that is a electrochemical impedance spectroscopy study. From this we can calculate the RS and RC, that is solution resistance and charge transfer resistance for that particular material. Then we used this thin film for fabrication of flexible symmetric supercapacitor devices. The process of fabrication of symmetric devices is shown in figure. Firstly, we coated that material on thin film on stainless steel substrate. Then we coated the then we coated some electrolyte, thin electrolyte layer on that material. After that, we fabricate the flexible supercapacitor device and we check their performance for actual demonstration with green LED. Further, characterization is a two electrode system characterization. So, for device, also we have to check the in case of a device, we are used two electrode characterization and similar characterization are used, like that is cyclic voltammetry. But in case of a device, we have to optimize firstly the potential window. So here we start from 0.4 to 1.2. So we got for our device, symmetric device potential window is 1.2, 0 to 1.2. Then we take the we for this device also we take the cyclic photogram at different scan rate from 5 to 100 and calculate the specific capacitance. But in case of a device, the specific capacitance is reduced due to the large area. And further, we check the galvanistic charge discharge study also for this material. And from that study also, we can calculate the specific capacitance for that device. And this is the actual means this is the characterization are used to confirm that the material is useful in device level also or not. So after that, the main characterization for device is like a energy density calculation and power density calculation. So in case of this device, the energy density and power density here is from this we can see that device showing the good energy density and power density also, and the capacity retention is improved in case of a device that is nearly about 90%. And we also checked the stability using the bending angle, means the fold device at various angle and measure its performance. In also the electrical impedance spectroscopy study also done in the case of device also. And further, my current research topic is photocapacitors, in which we combine the supercapacitor with photoactive materials or energy, another energy harvesting material. So why why we are using this one? So that is main challenges for you. Main challenges for this fabrication of device is like a increased device size, voltage mismatch between the energy harvested and energy storage. In my my research, I have used this kind of a device. This kind of a device combination, that is one part is a solar cell and another part is a supercapacitor. So I particularly use the organic solar cell type of, devices, and electrode material I used here is a p dot MOS2 combination, and which is dual functional. That is in this concept is a shared electrode, that is one that electrode can be act as a electrode in case of a supercapacitor, and also for solar cell also. So energy storage, main purpose of that is improved conductivity and capacitance and scalability in the supercapacitor. So why we used P dot PSP act as a doping agent and modify the electronic band structure of MOS2, enhances the electrical conductivity, and 2D MOS2 composite it from the composite with the MOS2 to improve the both photovoltaic and capacitive performance. Here I prepare just using the ultrasonic technique for fabrication of this composite. Firstly, we take the IPA solution and then P dot, just stir it after mix with MOS2 and stir it for 1 hour, and then use the ultrasonic bath to combine these two material. And these are the characterization techniques to use for characterize our photocapacitors, which is similar like a supercapacitors, but here we are using the two systems, so we have to use the some characterizations for solar cell also. My actually this is combined. My part is like a measurement of a supercapacitive property. And in this case, we will fabricate the device like shown in figure. And the characterization used for that photocapacitors are as shown in this figure. Like we use the in case of we measure the characterization in presence of light and in absence of light, and we measured another different characterizations like CV also, charge discharge also, and some characterization from solar cell also. Then here we will understand how the TRL is used in my energy storage. Firstly, in basic, first TRL is basic principle observed. That is exploration of fundamental principles of energy storage mechanism. For example, discovery of novel materials such as 2D materials or conducting polymers with a potential of a high capacitance. And main goal of this TRL first is understand the electrochemical reactions and ionic transfer. Second TRL is a technology concept formulated. Then description identifying how the new materials or concept can be applied to energy storage. So if in first we will check, we will consider different kind of materials and check it's a proper, like I shown in previous slides. We have to check it's a firstly we have to fabricate that material, then we have to check its a supercapacitive property using three electrode systems, and then identify its material, this material. In second tier we have to identify this material will be applied for energy storage or not. For that we have to use the three electrode system and check the property of that material. If it is showing some good performance, then only we can go for next, that is then the main goal of this TRL is a computer that is energy storage, study the energy storage mechanism and predict the theoretical performance. Then third one is experimental proof of concept. This in lab scale testing and concept using the basic setups. That is fabrication of small electrode using novel materials and measuring capacitance, life cycle, energy density in actual device or coin cells. Validate the facility of technology in controlled laboratory conditions. Challenges in in first three TRLs are the fundamental challenge in material discovery and synthesis. The main challenge for this TRL is identify the good material. So in initial slide I mentioned what are the basic requirements for that choosing the material, that is the porous nature, and it should having the good surface area and good conductivity. That are the important factors are used to identify that material and check its performance. Importance of interdisciplinary research means other factors affecting on that performance of that device. Then development phase, prototype development and testing. In this TRL4, component validation in lab environment, that is fabrication of energy storage components for rigorous testing in lab. Example, building a single cell supercapacitor like us with a new material and testing charge discharge rate, power density, and thermal stability. Then establish the repeatability, efficiency, and components under the controlled conditions. Fifth one is component validation in the relevant environment. Description in description testing the component in condition that mimic the real world uses. Testing the supercapacitor in a simulated environment with a varying temperature, load profiles, and similar to renewable energy integration. Prove the performance stability in relevant operation conditions. And then sixth one is a system demonstration in operational environment, that is integration of technology into the system level prototype for field testing. Employing that is developing a prototype supercapacitor model in a hybrid energy system with the solar panels and analyzing the real world performance. Goal is verifying the stability, scalability, and performance under the different operational conditions. Challenges for this TRL are scaling up lab result into the functional prototypes. Key technical barriers, that is energy density, cost reduction, and safety. As we discussed in previous, then another phase is development phase, pre-commercialization to market launch. That is system prototype demonstration in operational environment. Field testing the full system prototype in its final intended environment. Installing a grid scale battery supercapacitor, a hybrid system for peak saving or load balancing in a renewable energy grid. Demonstrate the operational readiness and identify potential issues before the commercialization. Then at the TRL is the system completed and qualified. That is the technology is fully developed, certified, and ready for the production. Completing the regulatory certifications for the energy storage system, ensuring the compliance with the safety standards, and producing pre-commercial units. Goal is qualify the technology for large-scale manufacturing and distribution. Then ninth TRL is the actual system proven in operational development. That is full-scale development of energy storage technology in real-world application. Example, commercial use of thermally chargeable supercapacitor integrated into the electrical vehicle or renewable microgrids. And in case of a photocapacitor, we can use in our watch and another shoe, like another factors in thermally chargeable supercapacitor. I am also working another project which is on thermally chargeable supercapacitor, in which we can use the heat generated by batteries in vehicles and convert that heat into convert that heat and into the energy and store it, and we can use further for other applications. Then challenges in this TRL is the navigating regulatory, manufacturing, and market entry hurdles, importance of the field testing and certification. The critical challenges are mainly increasing the energy density while maintaining the power density and life cycle life. So in supercapacitor, we already have good power density and cycle life, but when we combine with another material or we try to improve its energy density, it's the main task for us to maintain its its original power density and cycle life. Reducing the material and manufacturing cost. Along with that, we have to consider it shouldn't it should the process should not be costly, and enhancing the scalability and sustainability. The main factor is the scalability and sustainability and repeatability. So these are the main critical challenges. So development of a hybrid supercapacitor with energy density, and in case of my study, development of a hybrid supercapacitor with energy density closer to the batteries is main challenge. Then integration of thermal batteries to with the phase change materials for grid application. So these are the TRL mainly used in my energy storage study. And these are some my grant approved for projects. As initially told, I have worked around 3 projects. One from our DST, then another is from Japan, GSPS under GSPS fellowship, and third one I worked as a co-PI for thermally self-chargeable supercapacitor project, which I applied in UAE. So I acknowledge to GSPS to giving me the support for my fellowships. Thank you. And thank you for your kind attention.
Thank you, ma'am, for your wonderful session and for sharing your knowledge on the topic technology readiness level scaling from ideation to startup. Now we move to the question answer session. The forum is open for discussion.
Hello, good afternoon, ma'am.
Hi, good afternoon.
I'm Dr. Deepak Sawant from D.R. Patil University, Kolhapur.
Okay.
My product is now in TRL 6 level.
Okay.
So I need now biotechnology product is there. That is TB sensor for paper-based device.
Okay.
So I want to apply for TRL 6 level funding in India or also in abroad also. So can you guide me, please?
Actually, here I give my mail ID. I can just tell you in detail about that. Okay, you have to firstly apply for grant. You with miss. In my case, I take help from professors of their university, and they can know very well their technology, means their companies, and and they can. I like a bridge between us. So for UAE project also I did same. So that I am PI and that professor is main PI host for that. So they can provide us funding. So I can work from remotely also on that project. So yeah.
Thank you, ma'am.
Yeah.
Any questions from participant? Yes, any questions from participant? No, I think questions are over.
If anyone has any question, you can contact me personally. Here I give my email ID so I can talk in detail about that.
Yes, ma'am. Okay.
Yeah. If anyone want to collaboration, then also I'm ready to collaborate for any help. If you want any help for research or any other facility.
Thank you, participants, for your thoughtful and introspective questions, which led to a fruitful discussion. Now, we sum up the first session of today's FDP. I extend my sincere thanks towards our guest speaker, Dr. Anuja Yadav ma'am, for sharing her knowledge and enriching us with a wide spectrum of ideas. Thank you, ma'am.
Yeah, thank you.
Okay, Zokare sir.
Yes, ma'am.
There are some instructions for the participants for the feedback link. Participants has to fill the feedback link in portal itself. There will be two feedback links. One will be provided in chat box after completion of all these 3 sessions. So that link is also compulsory. With this, participant has to provide their feedback through ATAL portal Now the Vivek Bagchi sir has joined, so you can make him a co-host, and Inge madam, you can proceed for his introduction.
Okay, ma'am. मग immediately, ma'am, we will start the next session.
Yes, we can go for it.
Okay, okay, ma'am. Now, dear participants, we will resume the next session sharp after 5 minutes break.
All participants, please fill the feedback. Feedback link is provided in chat box.
Ubale ma'am, can we start?
Yes, ma'am, we can start now.
Okay, thank you, ma'am. Good afternoon to one and all. Now, I would like to take this opportunity to introduce Dr. Vivek Bagchi sir. He is a scientist and associate professor in Energy and Environmental Research Laboratory. He is editorial board member for Scientific Report, Institute of Nanoscience and Technology, Department of Science and Technology, Government of India. He is among the top 10% in CSIR NET examination and nominated for SPMF, and subsequently joined IIT Delhi, where he completed a PhD degree in area of catalysis. In 2009, he moved to the Missouri University of Science and Technology, USA, to join a postdoctoral research associate and continue for more than 3 years. As far as his academic honors are concerned, in January 2013 to till date, he is working as scientist at Institute of Nanoscience and Technology, Mohali. He was appointed as IPR Cell 2019 to 2023. He is having editorial responsibility as a editorial board member of Scientific Report, a journal of Nature Publishing Group since 2022. His major research areas are designing and synthesizing new nanoscale materials and structures with a emphasis on rational control of morphology, size, structure, composition, and doping of metal carbides, nitrides, sulfides, phosphides, oxide, etc. on multiple scales for energy and environmental applications. He is having many more publications and patents. He has invited for the talk in many conferences and symposium. Sir received grants from several funding agencies, mainly DST, SERB, etc. He has particularly activated in 4 projects worth more than rupees 15 crores, which includes 3 nano mission projects. He is life member of American Chemical Society, also Material Research Society Singapore, Indian Crystallographic Society, Indian Electrochemical Society. Now, I would like to invite Dr. Vivek Bagchi sir to start the session. Please, sir.
Am I audible?
Yes, sir, you are audible.
Okay, great. Yeah, good afternoon, everyone. First of all, I'd like to thank the organizer for inviting me in this faculty development program. And the topic is next generation energy harvesting for a cleaner, sustainable planet. So here we'll be mainly, discussing, hydrogen generation reactions and, some other conversion reactions as well. And, in order to understand this reaction, we'll also go through some of the basic aspect of electrocatalysis. Okay, so it is needless to mention that the carbon emission has been a major challenge nowadays. If you see, in I think almost 5 years back, the CO2 concentration in air in atmosphere has gone above 400 ppm permanently. When I say permanently, that means even if you stop the carbon dioxide emission today, the level of CO2 concentration would stay for another 200 years. So this is the seriousness of this issue. And if you see that by 2040 it would be around 35.7 gigaton per year. This is the amount of carbon dioxide that will be dumped into the atmosphere. And the consequence you can see nowadays, the surface are getting heating up. If you see, these are the mapping from satellite, and it shows that how the surface are getting heating up. And other problems are like acidification of oceanic water. With the almost 22 million tons of CO2 are getting dissolved per per day. Now this amount of carbon dioxide, when dissolved in water, then it also acidifies the water, and which actually prevents the calcification. In all seashells, those shells are basically of calcium. So this actually resulting in acidification and prevent this calcification. And that is why hundreds of species are going extinct day by day. So these are some of the parameters where it shows that which country is responsible for most CO2 emissions. As you can see here, China is at the top, and then United States, then Europe, and then India. So this is the situation that is there, existing there. Now, in order to prevent this kind of a situation, people are working on energy conversion reactions, basically like splitting of water splitting, for hydrogen generation, electrocatalytic water splitting, and then energy storage, as in metal air batteries, metal ion batteries, supercapacitors, hybrid devices, and then energy conservation by making more efficient devices like LEDs, etc. Right? So these are the ways that people are working on. So we are in our group also working on this energy conversion reactions, and energy storage, environmental remediation, and catalysis. So today I'll be discussing mostly on energy conversion reaction, and we have also made some developed some technologies for air purifier, which is a bit different, which can take away your ammonia and SOx, NOx, etc. Apart from the usual air purifier. So it can in hospitals, urinals, in slaughterhouse, animal house, you need a huge amount of ammonia is secreted. So in those places, this kind of air purifier is required. So it actually pacifies that kind of concentration, ammonia concentration in air. So usually normal air purifier can't do it properly. So this is the USP, and also it is reusable. So this is another thing which is environment friendly. And we are also working on smart glass. So usually you'll see in most of these new buildings, most of the building is covered by glass. So you can here by just changing the color and making it opaque, you can save a lot of energy. So in winter you might like to like the sunlight to enter the building so that it get heat up, and in summer you don't want it, so you can actually modulate the amount of heat that you want. So this is how you can at least save like 25 to 30% of energy. So that is a huge amount of energy actually. And this is another device, another technology we are working on. This is for nanoglass manufacturing, for where meat, fish, or this kind of food materials can be preserved using this kind of nano ice flakes. So these are very this can preserve for longer time, for 15-16 days. So these are the things that we are working on now. So we'll cover some of the fundamental electrochemistry and electrocatalysis here. We'll look into the thermodynamics and kinetics of the reactions, and then we'll go to the application part. Okay. Here some of the because many of you may have different backgrounds, so we'll just brush up some of the basics so that you can easily understand what we are discussing. So we all know about like what is catalyst. It is basically reducing the activation energy of a reaction. Okay, so this is how it works. So when you have catalyst, so it actually reduces the activation energy. Now catalysts, I have classified into 5 different type of catalysts. Here these are biocatalysts. These are extrement. This is a biocatalyst where you have all protein chains, and in between there is active site. And then some homogeneous catalysts are designed, which is kind of a mimic of your biocatalyst. Several reactions are being used where homogeneous catalysts are being used. And in the extreme right, it is kind of ultra high vacuum surface science, where you know exactly how many atoms are there and how many molecules are sitting on it, and you can actually regulate the reaction very well, and you know what is going on there. So after that, this conventional heterogeneous catalyst, where you have several nanoparticles, or heterogeneous catalysts, for example, catalytic converters of in ammonia synthesis, etc. But here I kept electrocatalysts in the middle, because it includes like left and right, both the things. So this is why so this is how I have classified this 5 broad catalysis. So photocatalysis is also a part of electrocatalysis, where you can see that how the water splitting can be enhanced by nanostructuring the catalyst. So these are the 3 key conversion reactions. Here hydrogen generations, and here carbon dioxide reduction, and then water splitting, of course. So these are very crucial reactions that and which can be used to produce your produce energy, which is kind of a environment friendly. Okay, now so before going into that, we need to know that, well, these are the basic things. We need to know about what is oxidation, what is reduction. Everybody knows it. So oxidation occurs at anode, okay, and reduction occurs at cathode. So this is all we know. Now, whether a reaction is feasible or not, that you can always get from this del G. So del G value, if it is negative, then it is the reaction is spontaneous. Okay, and you can always get from this for example, if this is the reaction, A plus B equals to AB, where this is the oxidation, this is the reduction, so this is the total E, and then NFE is equals to your del G, where if it is negative, that means it is spontaneous. So this is basically the redox, table of which you can follow, from which you can easily tell that, like, the electron will flow from which cell to which cell, okay, when you make the couple. So from here you can easily conclude. Now this is one of the interesting thing, based on this cell potential. In 1886, a French, one of the, from the French government, they gifted this Statue of Liberty to USA, United States of America. Now during that time, it was like this. Actually, it is made of copper plate, and the plate is made on a iron structure basically. Now after some time in 2012, they realized that huge, the structure is almost ruined from inside, and got corroded. Then this is a very simple thing. If you see the reaction, Fe, this is the Fe plus 3 plus 3 electron. So this is this is the cell reaction, as you can see here, and this is basically the oxidation is going on at Fe3, and Cu is getting reduced, as you can see here. So inside structure is made of your iron, and then if you see the E cell value is 0.36 volt. Okay, so it basically makes a total cell where it is, if you see del G is negative, so that is why the reaction is spontaneous on, and that is why the iron inside was getting oxidized. So it was an interesting revelation, and of course application from this electrochemistry. Well, while talking about electrochemistry, certain things are very important. So this is the electrochemical cell, typical, where you have this working electrode and counter electrode, and of course for degassing there is a gas bubbler, and then your reference electrode. So this is the typical cell that you have. And in certain cases, rotating disk electrode are being used. There is a reason for it. So I'm not going into details of that. I'm just giving you an essence of like how the potentiostat are being connected and how the measurement are being done here. And usually for a catalyst, the three things are very important. These are activity, stability, and selectivity. So these are the things that we look into. Okay. Now, for example, in one of this conversion reaction, remember we were talking about this conversion reaction, 3 conversion reactions. Now here, when we talk about hydrogen generation reaction, this is a one-step reaction, as you can see. But when we talk about this carbon dioxide reduction reaction, it is a multi-step reaction, and each step also involves a certain potential. So these are actually equilibrium potential. So when you say equilibrium potential, you should know that here, for the reaction, if we don't use any potential, for example, if it is kept at like 0 volt, then equal amount of these reaction will occur, and then equal amount of this reaction will occur. Okay, so ultimately it will be nil. The resultant the resultant product is 0, but the extent of conversion here and here will be there. Similarly in all these cases. So these are all reversible. That is why symbols are like this. So here, as you can see, at 0 volt, it is an equilibrium. So at from certain distance, this H2 is forming these ions, and then these protons are again getting reduced, and this is, the amount of formation in both these cases are same, but the extent, it may vary actually depending on the catalyst. So I'll come to this because this is very important thing. But you see that in carbon dioxide reduction, there are so many steps, and each step is associated with this equilibrium constant, equilibrium voltage. Okay, so at this equilibrium voltage, this reaction is it is not at 0, it is at minus 0.11 volt, where this is in equilibrium. Okay, here also it is different. Now in case of thermodynamics, we know that, well, if you shift it to positive or negative voltage, as soon as you shift from this, as per thermodynamics, the other reaction will start work. For example, if we turn this voltage to negative, this reduction will start. Okay, so it will shift. This reaction will shift to the right hand side. Whereas in this case also it is like that. If we shift to the right, change the voltage, this equilibrium will shift. So this is how this reaction will operate. Okay, now here we'll realize that not only the thermodynamics, but also the kinetic parameters are very important. Here, as you can see, this is a typical hydrogen generation plot, where this is hydrogen generation, where you are just increasing the potential. If you just increase the potential, negative potential basically, so you are increasing. So basically you have your cathode. Okay, so this is a cathodic reaction where you are pushing the electrons and the protons are getting reduced. Okay, so as you can see, it is a straight line, linearly increasing, as you can see here. As soon as you increase the negative voltage, pushing the electrons here, so these are getting reduced. Okay, so this is, you have to understand that here protons are there, so protons are getting reduced and your hydrogen generation takes place. But here in this case, where you have dissolved hydrogen, okay, you have dissolved hydrogen, where the dissolved hydrogen is getting oxidized here. Now here in this case, after some time, because the concentration of proton is very high and it is very labile, but in this case gas concentration of gas is not that much actually. So the concentration of gaseous molecule cannot be too much actually. So in this case, what happened, after a certain time, it becomes like this, because of at the vicinity of the electrode there is not too many hydrogen molecules left. So even if your thermodynamics says that it should go shift the equilibrium to the right, and the reaction must take place, but here, due to this condition, okay, the current become limiting. So this is called a diffusion limiting current. So we can see a lot of this in subsequent reactions. So this is one of the aspect, and this is in this case also like in oxygen evolution reaction and oxygen reduction reaction. So these are the two cases where you can see this kind of plot. Now I'm skip because there are too many slides, so I'll just skip some of the which are slides which are not that relevant now. Okay, now here, to understand the electrochemical reaction kinetics, how much current in a cell you are getting, and what is the contribution of anodic contribution and cathodic contribution. So this is given by Butler-Vohmer equation. This is a very famous equation and very important. So here the inherent kinetics of the reaction you can guess, and the effect of transfer, mass transfer is also there. Okay, here we talk about this diffusion, right? Here we are talking about diffusion limited current, because after a certain point of time the molecules are getting used up, and there is at the vicinity of the electrode there is no molecules, I mean less molecules, and the current basically depends on the molecules which are which are diffusing towards the electrode. So it basically depends on the diffusion rate. Okay, so that is why it is called diffusion limited current here. So this is this also relate with the kinetics. So here I equals to I0, where you have I0 is basically the exchange current density. I'll come to that. And then this term is called the anodic term. This is cathodic term. And these are like number of electrons. N is the number of electron. Alpha is transfer coefficient. F is Faraday constant. Eta is the O potential, and R gas constant. T temperature. Okay. And from here we also get the Tuffel slope. Okay, so I'll come to that, but before that I'll explain that exchange current density. Exchange current density I0, or in certain cases it can be noted as JH0. Okay, now here, as I have already mentioned, that how much from the equilibrium, how much it travels to the left hand side and how much at the right hand side. So this actually based on the kind of catalyst. So I0 is basically characteristic of a particular catalyst. If the catalyst is very good, then your I0 will be very high, and basically I0 corresponds to the extent to which this travels from from the equilibrium position to right or left. Okay, so these two are feasible, right, from this reaction, because it is in equilibrium. So without applying any potential, how much it travels to left or how much it travels to right, this reaction. So this actually gives in terms of I0, exchange current density, you can get the get an idea that how good your catalyst is. If it is exchange current density is very high, that means your catalyst is really good. And when we talk about this current, basically here how much amount of hydrogen is generated, it is basically corresponds to the number of electron that is being used up, right? So that is why you can correlate with number of charges and current, of course. Okay, so this is how it is correlated. Okay, now this is basically the Butler-Bowman equation. When you plot it, it would look like this. And from here, if you plot this log I versus this over potential, then you can get the Tuffel slope. And the Tuffel slope value has significance. I'll come to that later. So there are another thing is that the current densities, basically current per area, used to earlier this used to be the current density, the way it was calculated, and then the best way to do it using I'm not going into details about that. It is nowadays now we used to calculate using electrochemical active surface area. Okay, so usually over voltage is the voltage, that is the excess voltage that usually you apply to get a given current density at a given current density is always expressed. So here over potential is basically when you drive, for example, from an equilibrium, when you want to drive the reaction on the right hand side or left hand side. So that is the excess amount of potential that you apply, and that is called over potential. Now here, when we talk about over potential, we have to mention certain current density. So usually it is measured at 10, but you have to mention it that the over potential is such and such at certain like 40 milliamps per centimeter square or something like that. So you have to mention the at what current density you are measuring the over potential. Okay, so these are something that we should keep in mind. And typically, when you plot hydrogen evolution, it would look like this. So here you have the potential. So you are applying potential. So you have cathode. Okay, so you have cathode, you are applying potential here, pushing the electrons, and then the protons are getting adhered onto the surface and getting reduced. Okay, and as soon as the electron being used up, you are getting the current, and the corresponding current you can get this plot. Okay, and this is the current density. Basically, when you are using a certain area, so you get the current density accordingly. So this is how it look like. Okay, for a hydrogen evolution reaction, the plot is plot look like this. Okay, so as soon as you are pushing the electron, the current density increases like this. So if I say the over potential is 200 millivolt here, as you can see here, 200 millivolt. So it is at 10 milliamps per centimeter square. So this is the current density. And here I can say that at the over potential is around like 220 millivolt at 20 milliamps per centimeter square. So we have to mention it as soon as we talk about over potential. So less the over potential, better is your catalyst is. So less amount of energy you have to spend. Okay, less driving force, and you are getting higher current. That means you are having a very good catalyst. So this is how the catalyst can be compared. Now here in Tafel-Slope value, okay, as I have already mentioned, the Tafel-Slope value is if it is less, for example, for platinum C, as you can see here, it is very less. So it becomes more and more efficient. The Tafel-Slope, low the Tafel-Slope value, and lower will be the higher will be the efficiency, basically. Okay, so this is something that you have to note down before we go into the details. And another thing that we need to know before that all these reactions which operates here, basically there are two types of mechanism that is operating here, Volmer-Tafel or Volmer-Hierarchy. So here in case of Volmer-Tafel, what happens, these ions are getting adsorbed individually, and then it is getting reduced. Okay, and in this case what happened, one is reduced and another ions is then getting attached, and then further it get reduced. Okay, this is how these two reactions are operating. Now here one important aspect is that the interaction of hydrogen with the material. So as per this principle, this is a volcano plot. Okay, the interaction of this proton with this substance, this material should not be, interaction should not be too high or too low. Okay, so that after formation it can release. Okay, so it should not attract it too well, or it should not be, labile also, too much labile. So the interaction should be optimum. So that is why, del GH should be, close to 0. It should be thermoneutral. Okay, so absorption energy should not be too high, basically. Okay, so this is another point that we have to understand, and it can be usually by DFT calculation. You can calculate the del GH value for, with respect to its substrate. Now, one of the point that we have to understand that, well, in case of hydrogen generation reaction, it is because it is a one-step reaction. You can always, have and idea that, well, you should have, this kind of material, and you can, by just calculating the del GH, you can say that, well, this material would be good, for your hydrogen evolution reaction. But where you have, multi-step reaction, it is very, very difficult to, tune the catalyst, because in one reaction, for example, here, as we have seen, that, these potentials are basically changing. And for example, for this reaction, if you optimize the catalyst, then once, this is forming, then, the interaction of the catalyst surface actually changes, and it would be very difficult to, tune the catalyst for each substrate. So this is the reason why, for, multiple step reactions, it is very difficult to tune the catalyst. Okay, so I'm not going into the details of this. There are certain papers, you can go through it. I've just given it so that you can go through it and understand the significance of nanostructuring in hydrogen generation reactions. Okay, so this is what we were talking about, that in multiple reactions, multiple step reaction, it is very difficult to design the catalyst. Okay, these are some of the reference I have given so that you can go through later. So here, mainly we just had an overlook of how the conversion reactions are operated. Now we'll look into little deeper in the electrode kinetics a bit. So when you have already, I think, many of you know about this Helmholtz layer. So electrical double layer basically forms as soon as you put a metal strip in a solution, so there will be a double layer kind of thing, and this is called Helmholtz double layer. It is proposed by Helmholtz, and this is actually how it looked like. So there is a potential difference as soon as you put it. There's a potential difference from the surface and from the metal surface and the solution. Okay, so this is how the potential varies as soon as you go from the from the surface of the metal strip to the solution. So with higher distance, the potential will drop. So this is how it is dropping as per this Helmholtz layer model. But then Goy Chapman have given their theory that, well, these ions are not kind of a regularly stacked. It is kind of a diffused. It is in the diffused form. So the current the potential would vary like exponentially, kind of like this. Okay, so their proposal is like this. But then it also, Goy Chapman model fails for highly charged double layer. Okay, in case of highly charged double layer, it fails. Then Stern came up with a very intelligent model where actually he included both of these. So he said that, well, in the, when it is very close, is actually the Helmholtz model. So it is linearly decreasing, and then after that, the ions become very much diffused. It is not like, properly arranged. So it is kind of a diffuse. So it behaves like, exponentially decreasing like this. Okay. So this is how they explained it like that. So as you can see, so we can, measure this surface potential like this. So this is the inner, this is the outer, and this is the difference. So you get the surface potential. This is how you can do it. And the rate of charge transfer. Okay. Now your for example, in case of hydrogen generation, you are pushing electron from the cathode. Okay, and the deduction is taking place. Now just visualize this. Now here, the amount of material produced over a region of the electrode surface at some interval of time divided by area of that region and the duration of time interval. This is basically your flux of ions, that is ions or molecules that are coming out from the surface of the electrode. Okay, so this is actually flux of products. Now this can be given as with a rate constant. It is basically proportional to the number of species, of course, concentration of the species. Now in case of rate of reduction, so this is basically rate of reduction depends on the concentration of oxidizable species. Okay, similarly Kc into ox, and then similarly Ka is depends on the reducible species. So the total current for cathode can be given as, this is the charge. So this is a simple equation where for this reducible species, you will get oxidizable species, you will get the current in cathode. Okay, basically you can visualize that, well, protons are coming onto the surface of the cathode. Okay, and then it is getting reduced. Okay, so here what is happening, so the concentration of proton, which is basically to be reduced. Okay, so oxidized species, this is the oxidized species, this is the concentration of oxidized species. So you get the current for the cathode. Similarly for anode, you will get Ja. So the total current would be, of course, Ja minus Jc. So you get this expression. Okay, so this is basically a short form of your Butler-Homer equation. Okay, here Butler-Homer equation can be again expressed in terms of energy of activation. Now energy Arrhenius equation. So you just put this K, replace this K with this part, which is include the activation energy, as you can see here. So you just put it, so you get this activation energy. Okay, so you can also correlate that the activation energy basically varies from catalyst to catalyst. So the cathode material that you are using, so based on the cathode material, the activation energy will also, yes. Further, you can also see any change for a particular change, how this will vary. Now here, for a particular change, you can see that this del Gc is basically cathodic, and alpha is basically your transfer coefficient, the amount of reaction that it proceed. Okay, so alpha, the value of alpha is from 0 to 1. Okay, so for cathode it is alpha, and for anode it is 1 minus alpha, because if it is usually it is taken as 0.5, the value of alpha is taken as 0.5, and thinking that the transition state would be at at the 50% completion of the reaction. So basically it shows the completion of reaction. Now if the reduction takes place 50%, then the oxidation might have taken oxidized species is converted into reduced species 50%. Okay, so it will be like 1 minus alpha. So this is how you can further get further details in case of Butler-Bowmer equation. So this is the derivation basically of Butler-Bowmer equation. Now you can also get further details here. In we were talking about this over potential. Okay, let's discuss this in little detail. So when the cell is balanced, okay, against an external source, the galvanic potential difference, it can be identified as electrode potential. Okay, I'll tell you how to calculate the electrode potential. Basically, if you have a galvanic cell, for example, like this, so this is, you're putting some cell here, and this is a standard cell. Okay, you know that it is like 1.5 volt or 1 volt or something like that. So you know the voltage, and then this is R1 by this is R1 R2. Basically the length, this is a resistive wire. Actually this is a resistive wire where you can put here, so you can put certain position where it get balanced. So for a standard cell, you know that how, where this this point is. Okay, what is the value of R1 and R2, that in case of standard cell. Then you change it to unknown cell, and then you get a different ratio. From here you can calculate the electrode potential. Now here it is saying that when there is no current flowing, so the potential is called electrode potential when you calculate the electrode potential. And then when the current starts flowing, then it is no more, the potential is no more the previous one, so it changes it to a new value. Okay, so that is called the difference is basically the over potential. Okay, now in terms of over potential also, from here you can see that this J and JC can also be represented in terms of over potential. Okay, F is basically F by RT, that is written in this fashion. So yeah, so this is the smaller form of this Butler-Bowmer equation, and there are conditions where it depends on the over potential, when it is less and when it is high. So based on that, when it is very less, then this equation becomes, because it is e to the power 1 minus a fn or f eta minus e to the power minus a fn f eta. So here, as you can see, we know that e to the power x equals to 1 plus x plus etc, x square. So this is we know, right? So from here it can be deduced that the J equals to Z0 F eta. Now here the above equation illustrates that at low over potential, the current density is proportional to the over potential. Okay, current density is proportional to the over potential. Now in case where it is large and positive, large but negative. So when it is large and positive, you see that basically your current becomes a contribution of only you will get contribution of basically your anodic current. So when it is large positive, it is basically anodic current. If it is large negative, then it becomes contribution of cathodic current. Okay, so this is, from here you can get lot of information. So Butler-Bowmer equation is very important. Now this is basically how it look like. So in general, exchange current density are large when the redox process involves no bond breaking, or if only weak bonds are broken. Exchange currents are generally small when more than one electron needs to be transferred, or multiple or strong bonds are broken. So basically, exchange current density, if the reaction, as I have already mentioned, that the reversibility, if it is very labile and reversible, the reaction, then and to high extent it can go, then the exchange current density will be very high. But in case where some bond breaking and is takes place, then it becomes very difficult to for the reaction to be reversible. Okay, so that is the reason why in general, if some bond breaking take place during these reactions, then the current exchange density would be the exchange currents will be low. Okay, so another technique that we need to know here is voltammetry, where the current is monitored as the potential of the electrode is changed. Okay, and chronopotentiometry is the potential is monitored as the current density is changed. And the applications are kind of you can identify the species as well as determine their concentration. And while doing this, you need to know about some of the electrodes which are being used. So we have mentioned about electrodes in one of these previous slide. So we need to know like what are the electrodes that we are using. Basically, non-polarizable and polarizable electrodes are those basically non-polarizable electrodes where their potential only slightly changes when current passes through them. So such as calomel electrode, hydrogen electrode. And that is the reason why these are used as a reference electrode. Okay, this is what you have to remember, that reference electrodes are basically non-polarizable. Very slightly change occurs even if the current passes through them, when current passes through them. So, and that is the reason for choosing them as a reference electron. Whereas polarizable electrodes are those where strongly dependent on current. So as soon as you change the current, potential also varies. Okay, here there are majorly three type of voltammetry that is being used: potential step voltammetry, linear sweep voltammetry, cyclic voltammetry. And there is another one there called pulse voltammetry. I'm not going into details about that. So here voltage or series of voltage are applied to the electron, and current is monitored. This is what you have to understand. So certain potential is applied, and then how the current is changing. So that is what you are looking at here. Basically main components are electrodes, and then solvents and background electrodes are being also used. For example, if you are using organic solvent, so in those cases some supporting electrodes are being used. Okay, so these are the things that are being regularly, basically used, primarily used for the measurement of the reaction. So here in step voltammetry, as you can see, it is basically changing from V1 to V2. You are changing the potential from V1 to V2, and then you see the current, how the current is. You monitor the current. So first the current is increasing from V1 to V2, and then it is decreasing exponentially. And then here, as you can see, it is metal ion concentration versus your distance. So the distance from the electrode, as you can see here, the concentration with time, the concentration from the vicinity of the electrode is basically decreasing. So here there is a gap, that is concentration gap, that is producing while you are from cycle to cycle. As soon as you doing one cycle and then the other cycle, the concentration of the metal ion is getting reduced like this with respect to time. Now this actually lead to concentration polarization. Okay, so at low current density, the conversion of electroactive species is negligible. Okay, so when your current density is low, the conversion is very less. At high current density, the consumption of electroactive species close to the electrode results in concentration gradient. Okay, so there it becomes a concentration gradient. Okay, so once this is being consumed, so there is vacancies of metal ions with respect to the bulk. So this is what it's saying. So this is called concentration polarization. What is that? The consumption of electroactive species close to the electrode results in a concentration gradient, and diffusion of the species towards the electrode from the bulk may become rate determining. Therefore, a large overpotential is needed to produce a given current. So, for example, you are getting a current, okay? After certain potential, what happens? Here, the concentration along the electrode surface is getting less because these are being used up. Okay, so it creates a vacancy of your metal ions, and to to get the same amount of current, what you need, you have to push the ions further. So the ions are basically it will diffuse from here to here, so it becomes diffusion dependent. So that is the reason why you have to use more potential. So a large over potential is needed to produce same amount of current. Okay, so this is called concentration polarization. Okay, and here in terms of your derivation, as you can see here, will not go into details. So this is the Nernst equation, and from here, as you can see here, the sorry. So with time, as you can see here, this is the concentration of the excuse me. Okay, so as you can see here, this is the concentration of the bulk. Okay, and as soon as you go towards approach towards the electrode surface, you can see that the concentration is getting decreased. Okay, so this is kind of C dash. Okay, and this is called Nernst diffusion layer. Okay, so this is the distance from where the concentration gradient starts. Okay, so from here, as you can see, to push these metal species, ion species towards a lower lower concentration region, you have to push more voltage, right? Potential. So this is called your concentration this is concentration polarization, and this is called polarization over voltage. So this is the extra voltage that you have to give in order to achieve the same amount of current. Okay, so this is how you can get the concentration over potential. Okay, concentration over potential. This is how we have to calculate. This can be also relate to the diffusion. here the thickness of the non-diffusion layer is typically of 0.1 millimeter, and don't confuse with your electrical double layer, which is less than 1 nanometer. So this is not electrical double layer, it is of the order of 0.1 and this is electrical double layer is less than 1 nanometer. So don't confuse with that. The concentration gradient dc dt dx, okay, concentration dc dx can be given by this. So you can actually get this flux actually, okay. So because it is a diffusion dependent, so you can always correlate with the diffusion coefficient. So here you can correlate with the diffusion coefficient. This is the difference in the concentration from bulk to your electrode surface, kind of. So the maximum rate of diffusion across the nonce layer is when C dash equals to 0. So it is at maximum, C dash becomes 0. There is no concentration of metal ions, all are used up, okay, at which the concentration gradient is the steepest. Okay, here as you can see here, it is the steepest. So using the Nernst-Einstein equation, you can also correlate this J limiting with your ionic conductivity. So these are the expression where you can correlate these things. Okay, now let's come to the linear sweep voltammetry. Linear sweep voltammetry is this LSV is very important for hydrogen evolution reaction. Almost every time we are measuring it. Okay, basically you are increasing the potential at a certain rate, okay, at a certain rate, and then you get the corresponding current. So this is how you do it here. And in linear sweep voltammetry, a fixed potential range is employed, much like potential step measurement. However, in LSV, the voltage is scanned from a lower limit to a upper limit, as shown below. Okay, so this is how you increase the potential from here. Okay, and another thing that you have to understand, that the scan rate, for example, how fast you change from V1 to V2, this scan rate, based on that, your current also will vary. At higher scan rate, you'll get high current, lower scan rate, you will have low current. But one thing, important thing, is that your peak current, these are basically the peak current. This peak current, the position of the peak current would be same. Okay, the position of the peak current would be same for this. So this is how the LSV works. And then cyclic voltammetry is just that, from V1 to V2, and then you again change from V2 to V1. So you just return back. So that is why it is called cyclic voltammetry. Okay, from V1 to V2 we were going there, and then from V2 to V1, and you get a symmetric plot like this. It is, I'm showing it like this. Okay, this is how do it. Therefore, you start here, oxidation takes place, and then reduction. Okay, so you start here, and oxidation, and then reduction. So symmetric peak you will get this. Okay, in certain cases where the electron transfer, so here basically, as you can see here, you have oxidation. That means your electrons are getting removed, and then here reduction, where you are adding the electron, right? So this process is totally reversible, and as soon as you oxidation takes place, you get this, and then reduction takes place, you get this peak here. So in certain cases, if the electron transfer process is slow, okay, it is not at par, okay, then you will not get this kind of reversible plot. It would be not like this. Okay, it would be not like this. So it would be somewhat like this. so the pattern would be symmetrical. So these are very important. So from a cyclic voltammetric plot, you can easily tell that whether the reaction is reversible or not. It's very important. Well, let's come to our research topic now. Here, for hydrogen generation reaction, mostly we are working on heterostructures, and we have seen that when you make heterostructures, the interfaces, creates miracle actually. So it can be of, you can use like metal chalcogenides, transition metal chalcogenides, metal nitrides, carbides. Okay, so these are the materials that you can use which are electrochemically active. In certain cases, we have, in many cases actually, we have seen that transition metal hydroxide oxides. Okay, those are also, when combined, when they make heterostructures, they can do miracle. They they can be used for enhancing the catalytic activity. So let's come to the hydrogen evolution reaction again. Why hydrogen? Hydrogen has a high gravimetric density, energy density. It is a fascinating energy carrier. No pollutants are formed after combustion, and its conversion to heat or power is simple and clean. Okay, so and we talk about, and also we can, this can solve the twin problems of depletion of fossil fuel and reservoir, fossil fuel and carbon dioxide emission, which is main concern nowadays. And we also talk about this volcano plot, right? Now, as you can see here, in the peak, which is a very good commercially available catalyst, is basically platinum. Platinum is, in most of the electrolyzers, platinum are being used. But the main problem with platinum is that it is highly expensive. It is a trace element, highly expensive. So even if you produce hydrogen out of it, the the price goes really high. Okay, so this is the reason why a replacement of platinum with alternative materials, or similar or better activity we are looking for. So this is the objective. So here we have to understand that in order to find a good catalyst, there is not one parameter. There are several parameters that you have to optimize. Here, as I have mentioned that earlier, we talk about over potential, right? So over potential has to be less. So yeah, once you think about a catalyst, the over potential has to be very low, so that it doesn't waste any potential. There, you don't have to drive the reaction. You don't have to use a lot of energy to take the reaction. Okay, and the Tough-Slope value should be low. As I have already mentioned, Tough-Slope value has a connection. It indicates which direction the reaction is going. Okay, I'll come to that. And conductivity. Okay, conductivity should be high. Conductivity of the electrode should be high, and it should have optimum hydrogen binding. So we discussed about this volcano plot where I mentioned that the binding energy has to be optimum. If it is too high, if it is too low, then it will reduce the reactivity of the reactivity of hydrogen generation, and the reaction will decline. It will not happen properly. And of course, stability. If you have a very good catalyst and it is not that stable, then it doesn't make sense. Okay, so it has to be really, really good, stable, right? And regarding the Tough-Slope value, as I have already mentioned, and it is expressed in terms of millivolt per dec. Okay. Now, if the value is low, that means this just depends on the adsorption of hydrogen. Okay, and the material. We talk about this hydrogen binding energy. It depends on this only. If you get 30 millivolt per dec. Now, if it is around 40 millivolt per dec, then this Hierarchy reaction mechanism is taking place. We have discussed about this. So this is the Volmer hierarchy and this is Volmer Tuffle. And if the reaction, the Tuffle's value is really high, around like 116 or more than that, 120, then that means electron transfer to the to the interface is rate determining. Basically, when I say rate determining, that means the slow step is your electron transfer. So your catalyst is not that good, and that is why the electron transfer from the electrode to the electrolyte from the interface, it is very slow if you have high Tuffle value. So this is why just by looking at Tuffle value, we can interpret about the kinetics of the reaction. Okay. Now in one of this reaction where preparing catalyst out of several carbon sources, for example, soybean, peanut, bamboo stem, etc. These are basically a carbon source. And then once it was carburized with ammonium molybdenum, so it was thought that molybdenum carbide will form. Okay. And then it was realized that with soybean it gave very good catalyst. So for like more than 500 hours it was giving very good catalytic activity, and with a composite with RGO it is even better. So the over potential obtained was around 109 millivolt. Okay, which is, and commercially available PTC is 61 millivolt. Okay, so that you will have an idea that you can compare with the commercially available electrocatalyst. So it is 61, it is 109 millivolt. Then after analyzing, it was found, okay, after XRD analysis and all that, it was found that 55% of molybdenum carbide and beta M2C and 45% of molybdenum nitride is formed during the reaction. Okay, so 55% of molybdenum carbide and 45% of molybdenum nitride. So you can imagine that, well, in case of soybean, it is happening. Okay, so in case of soybean, it is giving very good catalytic activity, as you can see. Okay, and so after analysis, it was found that molybdenum carbide and molybdenum nitride are in the ratio of present in the ratio of 55% and 45%. So we realize that now we know that yes, this is the weight ratio. Just by changing the ratio of this molybdenum carbide and nitride, we can get a very good catalyst. Now that we know that this is present in this ratio, and also exam studies were done, and it is also it is also showing the same ratio. Here the characterization shows that, well, molybdenum carbide and molybdenum nitride are kind of it is kind of a small nanoparticles of 10 to 15 nanometer. So molybdenum carbide and molybdenum nitride nanoparticles are actually embedded on the carbon substrate. So this is what is observed. And it was properly characterized using this high resolution TEM and other characterization technique. I'm not going into details about that. The interesting part is that now what we did, we tried to sim, because many times it happens that when you do we'll come to that. Here the interesting part is that mere mixing in a similar proportion of nanoparticles. So what we did, we synthesized molybdenum carbide and molybdenum nitride, okay, and mix them physically, so 55% of molybdenum carbide and 45% of molybdenum nitride, just mix them and then try to see if there is any whether we can get that kind of efficiency or not. But interestingly, as you can see here, just by mere mixing it doesn't happen like that. Mixture doesn't happen like that. So mechanically, just mixing doesn't give that kind of. Then we realize that there must be some synergistic effect going on. If you really want to make them, then you have to synthesize in situ. That is what we thought. That is the point that we understood. So then we selected several carbon source, and then carbon source, nitrogen source, and metal source, and then devised a methodology where we could standardize the synthetic process. Okay, this is solid state reaction where these reactions are this reaction condition is standardized. And we just first started with cotton fiber, so it is kind of a carbon source. And as you can see here, this is a EDAX mapping where you can see very small these nanoparticles are forming. As you can see here, these are the nanoparticles. So all three together, this is the yellow, these are actually the nanoparticles that is homogeneously formed. Okay, and we got around over potential, which is around like 200 millivolt. Okay, this is MOCOT, got it around like 200 millivolt, so which is still more than what we got there. Okay, then we realized that something is the problem with selecting biomaterial is that it may vary. It might not be that much reproducible. For example, if I take soybean from here in India and soybean from somewhere in US or some in England, the composition might vary. So we wanted to make sure that we take standard material source and then reproduce the reaction. Let's see what happens. Now here, another thing that we realized that, well, the composition here, when it becomes the molybdenum carbide and molybdenum nitride composition is when it is close to like 40 to 50%, then it becomes very special thing. Okay, so this is what we realized from these reactions. So then, sorry, here we could really worked on this molybdenum carbide nitride nanoparticles. We realized that the synergistic effect can be observed only when we can make these molybdenum carbide and molybdenum nitride nanoparticles in situ. So then only we can get such activity. Now here, carbon supported molybdenum carbide and nitride nanoparticles of size ranging from 8 to 12 nanometer, that is synthesized, and this over potential of 96 millivolt at 10 milliamp per centimeter square we obtained. Okay, so this is what, and is, as you can see here, this is PTC. Okay, so which is around like 61 millivolt, as I have mentioned. And then we got, for this catalyst MOCAT, we got it around 96 millivolt. Okay, here 96 millivolt. And also the toughest value we got is around 37. And for PTC it is 34. And impedance study also shows that the charge transfer resistance is pretty low, very low. Okay, charge transfer resistance is very low. And we have also done it for like 1,000 cycles, but actually we have done it for like 3,000 cycles. There is no change actually. Here in paper we have done it, but we have checked till 3,000 cycles. There is no change in, there is no significant change at 10 or 20 current density. Okay, and these are the Ritwell refinement where we could calculate the amount where the molybdenum carbide is 47%, molybdenum nitride is 53%, and then we have used synchrotron facility from RRCAT to do the Zane study, where you can see that the oxidation state you can see for molybdenum nitride and molybdenum carbide are and our catalyst are pretty much the same, which is different from this ammonium molybdate where the molybdenum oxidation state is higher. And here you can see the examples where this is for the molybdenum nitride, this is for molybdenum carbide, and this is for both of this. Okay, where you have molybdenum carbide and nitride. Okay, this is the examples fitting. So one thing we realized, another thing we realized that molybdenum carbide is much more active than molybdenum nitride, and however the stability is not good, whereas molybdenum nitride is not that active, however stability is very good. So when you combine, there is a synergistic effect. Okay, so this is something is there when we realized that there is a when we analyzed this high resolution TEM. From this image you can see that it is kind of a highly porous material, and further observing, analyzing, we realize that there is an interface, there are interfaces everywhere, like everywhere in the material, interface between molybdenum carbide and nitride. Okay, these are the interfaces that we got. Interestingly, after theoretical calculation, we realized that, well, here as you can see, the molybdenum carbide and molybdenum nitride, they have very high negative adsorption energy. Very high negative adsorption energy means that it has a very high tendency to attract the protons. But because the it is very very negative, that is the reason why it won't be labile. Okay, so this is the reason why the molybdenum carbide and molybdenum nitride are not at all good catalyst, because it has a high affinity, but it will not leave the catalyst, leave the protons. Okay, on the other hand, when you have this molybdenum carbide nitride nanoparticle, that heterostructure, that interface is forming, that is positive. So on the other hand, you have a very high negative which actually attract these protons, and then at the interface you have positive, which is bit reluctant, which is very close to this surface, which is reluctant to which is actually try to keep up the molecules actually. So here it is bit positive, and here these are this is negative, highly negative. But when you make the heterostructure, this effect, this positive effect, is basically percolates through the nano layer, and that is why it is making this heterostructure so special. And this basically help, and once it is adhered to the surface, and then the interface basically help remove the product, already reduced molecules. So this is what we realized from the reaction. So I hope I'm almost done with my slides. So I'd like to thank INST, ACRB DST, and Technology Program DST, and several other facilities. Of course, many of my collaborators, and of course, all my students, for all this work. So thank you very much. If you have any, questions, you can, go ahead.
सर हमारा एक बिल पेंडिंग है
बाद में वहाँ पे C33 में बात
C33
yes.
If participants are having any question, please raise your hand, or otherwise you can put your questions in chat box.
So what you can do, you can go through the slides, and if you have any anything related to the research work or anything, you can always you can get in touch. Okay, so
Yes, definitely. If participants are having interest regarding this research, I will provide your contact number or email to them.
yeah, sure.
Okay, thank you so much. Ingrid madam?
Yes, ma'am.
Okay, you can proceed further
Okay,
process.
okay, ma'am.
Okay.
Thank you, participant, for your patient listening. Now we sum up the second session of day 6 of the FDP. I extend my gratitude towards our guest speaker, Dr. Vivek Bagchi sir, for sharing his knowledge and enriching us with a wide spectrum of the ideas. Thank you, sir.
Okay, thank you.
Now we will come back after 5 minutes break.
Zokare sir, please add Ingrid ma'am also as co-host.
Ubale madam, are you there?
Yes, madam.
Whether we will start next session immediately or we will take the break and we will start from 5?
4:45 we will start.
Okay. Okay.
Gokare sir.
Dear all participants, we will resume the next session sharp after 5 minutes break.
Zokare sir, Dr. Suhit Gilla sir had joined the session. Please make him co-host.
Yes, ma'am.
Ubale ma'am, shall I start the session?
Yes, ma'am, you can start now.
Okay, ma'am, thank you. Good evening to one and all. Now, I would like to take this opportunity to introduce Dr. Suhit Gilda sir, who is Managing Director at Jnanesh IP Services, Satara. He has completed PhD in Pharmaceutical Sciences from Bharati Vidyapeeth, Deemed University, Pune. From August 2004 to September 2006, he worked as a junior research fellow at Department of Quality Assurance Techniques, Bharati Vidyapeeth, Deemed University, College of Pharmacy, Pune. From November 2006 to October 2010, he worked as a senior research fellow at Department of Pharmaceutics, Bharati Vidyapeeth, Deemed University, College of Pharmacy, Pune. He has completed diploma in intellectual property law. He is working as knowledge transfer partnership associated at University of Bradford. His major research areas are concerned. He worked on the project development of novel extraction system for phytoconstituents and formulation development for different physiological disorder, preclinical and clinical evaluation of phytoformulation using various in vivo as well as in vitro techniques. As far as academic honors are concerned, he is a recipient of Maheshwari Ratna Special Critics Award in 2013 for excellence in field of science. He has received Dr. APJ Abdul Kalam Lifetime Achievement National Award in 2019 by International Institute for Social and Economic Reforms. Also received Me Padvidhar Award in 2019. He got National Doctoral Fellowship by AICT New Delhi for PhD in 2008. He has qualified GATE in 2004 conducted by Indian Institute of Technology Delhi. His publications are 26 in international journals and he is having 7 patents on his name. Now, I would like to invite Dr. Suhit Gilda sir to start the session. Sir, please.
Good evening.
Good evening, sir.
Good evening. Am I audible properly?
Yes, sir.
Okay, thank you. Thank you so much for the introduction.
Thank you, sir.
Slides are visible.
Yes, sir.
Okay, thank you. Thank you so much for giving the introduction and giving me opportunity to share my views, my journey. Throughout last 20 years, we have been working on such topics such as research-related projects from diverse areas like pharma. Then we are also working for water resource-related projects and so on. So I think so. Previous speakers for last 5 days must have covered the topic about patent, but I will like to go through some primary uh, discussions about what exactly mean by the intellectual property rights, though it is a common topic related, but it's like when we are working on awareness about the intellectual property, and we have delivered so many lectures for many institutions, and when we have concluded that nothing is working, because we are just trying to motivate uh, to file patents, but we are lacking, or we are missing the point that the students or the professors who are having idea, they are inclined towards publications on primary side. So we have thought that no, we will try to give some examples, or say the practical orientation for filing a patent or creating a platform. And I am sure that the today's session will definitely try to emphasize on not exactly how to file a patent, because that is a technical procedure, and it is available online or by the government of India at very in an easy manner. So we will go through some intellectual property rights related points, like what is exactly mean by the patents, what are the patent rights, what is the purpose of the patent system. And we will also cover with the patentable and non-patentable inventions, and how we have to define those inventions in the category of patentable, and how we can enhance the area of patent invention. Then patent types are what exactly mean by, what is exactly the patent filing procedures, and what are exactly the career opportunities. To be very frank, when we are dealing with the patent system, and we always try to believe in Saraswati to Lakshmi approach. So when we say Saraswati, because it is related with the intellectual property, and unless and until we are converting intellectual property in the business, or in the entrepreneur point of view, or in the form of money, then and then only we can have a really valuable system. So when we are dealing with the intellectual property rights, so these are the territorial rights which are granted to creator or owner of the work. And this is typically given to the scientific works, industrial works, or we can say in terms of copyrights, it is given for the literary or artistic work. There are many creative ideas or creation of mind. When we are saying the creativity, uh, when we are like thinking about an idea, when we come up with the idea, and we say any a new design is there, we call it as invention, which uh, sometimes called as a work of art, which solves the problem in new ways. And so from all the backgrounds, we can say the invention can be possible, and it must have a novelty, or must have some unconventional approach. So human intellect or talent is one's property, and that is the point when we are saying the intellectual property rights are there. So in terms of IPR, it covers patent, trademarks, copyright, plant breeders act rights, utility model or designs patents are there, geographical indications, and trade secrets. So as you all know from the CV which we already presented, that I am coming from the background, like from the pharma background. And uh, I will like to say that I have worked with automobile industry. I have worked with design industry, where number of designs for some industrial areas were developed. So it's nothing to deal with that I am from the pharma background, that I should only work for the pharma sector. No, it's not there. It's from the all the areas of science, or wherever there is a challenge or there is a problem. So we have opportunity to deal with it, and we can come up with a IPR. So intellectual property in terms of trademarks. So this is again a new area where we can work in a professional way to register trademarks. because these are also gaining some insights right now. So you can all the Coca-Cola is there, Facebook is there, McDonald is there. So all the trademarks and the different symbols are covered under the trademarks. Then we are having the copyrights, so literary works and artistic works. Few days back, I was working with a professor from an institute, and he is asking for how we can have our intellectual property portfolio to get enhanced or get a valuable base. So he said, can we work on such a design or some graphical representation, and can we get a design patent for that or copyright for that? Can it be get added to our portfolio? So I said yes. So many of us are particularly having their demonstration skills are there, so which can be covered under the copyright. And I think so. As per NAC or NB, I'm not sure about it, but I think so. They are also giving some credits for copyrights also. Uh, Even though books are there, some graphical representations or some what we can say the typical diagrammatic representations are also covered under the copyright. So it's not the only case that you are having a scientific or typical practical work which can be covered under the inventions, but yes, graphical representations and all those works are also covered under the copyright. Then we are having the plant breeders right. And to be very frank, most of the plant breeders rights are in India right now. We are covering for the development of farming industry. Then we are having the industrial designs, which are have been specially covered under the act, and where we can have designs. So there is a classic example when we were having the Tata Nano project. So we have covered approximately 3,580 designs under that Industrial Designs Act. So that is the thing what we can have. Then we are having the trade secrets. So many of us are well aware about the secret recipes or secret composition for many things. So I'm just taking an example of a food product, but we can have different composition secrets about some minerals, some about ores are there. So many of those trade secrets are also covered under secrets under the intellectual property rights. So we are also having the intellectual property in the form of geographical indications. So say, for example, the Kolhapuri chappal is there, Jaggery is there, and many more. And recently we are coming up with many geographical indications in terms of Paithani, so which is the classical sari from the region in Maharashtra. So what exactly the patents? So patent look like it is exclusive monopoly right granted by the government and to the inventor for his invention for a limited period of time. So it's all for only for the 20 years. And this is the right which gives us to exclude others from making, using, selling, offering for sale or importing the patented invention. So typically, but if we are trying to look out the scope of the patent, it gives us right to sell, to use, then for import or export. So it gives us exclusivity to use it, and we can use it in terms of as a property. It's a typical like a uh, immovable property, what we are having, the land or the house or any vehicle, like as same thing. So it is nothing but it is something like we are fencing our land, and how much we can fence it out, or we can like a compounding our land or house. It is same as that of the patent right. So typically it promotes the protection of inventions, and hence it encourages the inventions to have more and more emphasis on. So it is typically a territorial right. It is giving, it has only a lifetime of 20 years from the date of filing. And it is a proprietary right. So we can say it's a kind of intellectual property right, which is being a personal property and exclusive legal right. So we will try to identify what are the patentable and non-patentable inventions. So patentable inventions must have, it must be new or novel. It should not be obvious, and it must be have industrial application as far as it's concerned. So I'm just summarizing those points because already it must have been covered. So I'm just trying to emphasize on the fear points, like it must have inventive steps. Most of the time, students or researchers or inventors try to gain more and more on the utility, but they often fail to identify the inventive step when they are filing their application. So typically, according to the Patent Act, inventive step must have a technical advance. Then we have to prove that it must have economic significance, and it should not be obvious to the person's skill in that. So merely we are adding sodium chloride in water, and when we are saying yes, it is an invention, just try to grant us a patent. No, it's not possible. Or merely a mixture of one or two compounds and coming up with a new formulation. So it is not, it is obvious one. So a few days before, we have a invention from institute, and which were saying that we are having a lamp holder which is having different types of connections, and it is just a summation, or we are just adding different applications to that lamp holder, like a USB charger is there, and it is something. So the inventor is asking for a patent, but we say it's not applicable, or it is not possible to get a patent for such type of invention. So you should go for some design patent for that, because it is just a addition or just a summarizing or like invention. So it is not patent according to the Patent Act 1970. So when we are dealing with the non-patentable inventions, which are typical one, the laws of nature are there, the inventions which causes serious prejudice to human, animal, or plant life. Uh, we will try to give an example of from US Patent Office. They have given a patent to an instrument which can be used for pickpocketing instrument. Uh, so it's like that pickpocketing instrument is there, and US Patent Office has granted a patent for that. So such type of inventions are not possible in India. We can't, our Indian Patent Act doesn't allow such type of inventions to uh, grant a patent. Then method of agriculture or horticulture is again not advisable in Patent Act. Then mathematical or business methods, plant and animal in whole or any part thereof, because we have given a different provision in intellectual property law. Then literary or dramatic, musical or artistic works, which is again not covered under the patent, but can be covered under the copyright area. So different patent types we have to cover. So when we are saying uh, product patent, typically it is related with the patent claiming new chemical entity or new product to whole sum. Then we are having the composition patent. So just taking example of pharmaceutical composition of product, or we are having something new, first time in the world, what we can say. Then process patent, most of the, I think so, engineering patents are from the process patent point of view. So method of manufacturing a product and involving a different components with that thing, that is possible under the process patent. And we can also cover the method of use. So which are like a patent claiming in indication or use of that product. so can be used as a patent. So different patent application types are there. So provisional, which is the most useful provision given by the Patent Act 1970, where we can having a provisional application. When we are dealing with the provisional application, it is the most, what we can say, it is our uh, even though we are having a very good provision to file a patent, when we are having just an idea, when we have not even thought about how it will work, it is only for an idea, we can file a provisional patent application. So complete specification. So complete specification patent application is for with claims and abstract. It is like a complete application which covers the boundaries or the legal boundaries of our inventions, what we try to protect. Then divisional, so which is a file in case of plurality of inventions. So many times what happens, we file a patent application, the complete specification, and after few months or few years, we try to have another inventions, but which are related with that original application. And in such case, we are having divisional patent application. Addition of that, so we can modify or improvement for the main inventions, which is possible. Then cognate application, which is like combining two provisional applications, so which is again a provision, the really useful provision given by the patent applications, because when we are having just an idea, we niche idea, and we try to cover those idea, and after some days we try to have, okay, yes, we are having a new idea and we can combine that idea. So that is like a cognate idea. Then convention, taking priority from earlier patent applications filed in the convention country. It is as per the treaty, and where we are having the convention application. The patent cooperation treaty, which is in terms of international applications. So according to the World Trade Organization, so we are having a provision to file applications and which will get applicable uh, to approximately 186 countries at a time. And only thing we have to go through that their national phase for getting application. But PCT application has a good array of benefits. So we will try to summarize what exactly the patent procedure in India. So exactly about the, when we are having idea, we will file a provisional application. After, within 12 months, only within 12 months, we have to file the complete specifications. Then complete specifications within 18 months, it will get publication. Now it is open for pre-grant opposition. Also, we have to file a request for examinations, and first examination report is released. We have to fulfill this first examination report. In such a first examination report, we have to satisfy or justify the claims or the questions raised by the examiner. Then after first examination report is successfully fulfilled, we have to uh, uh, that is the completion of first examination report. We have to intimation of grant of communication from the patent office we get. Then automatically the grant of patent is get published, and now it is open for post grant opposition, where we have to fulfill any opposition raised by the person in interest. Then the patent certificate is issued. So this is in short a process. And if everything goes well, we can have our patent at the earliest within 2 years, max to max. If everything goes in a perfect way, then if there are no pre-grant oppositions, there are no post-grant oppositions, and everything is as per the examination or the control suits feel that yes, it is fits properly. Then importance of patent, definitely for the regulatory point of view, patents are most important, whether in the terms of pharma, whether in terms of medical devices, whether in terms of import-export thing. Then marketing point of view, patent adds huge credentials as far as R&D is covered. So we always having four phases of patent types like para 1, para 2, para 3 and para 4 filings are there. So when we are working with para 1, so there are no inventions in such field likewise. And para 2, where invention patent is there, but it is already expired. Para 3, the patent is about to expire within few years. And para 4 is like patent is there and still it is having a lifespan of approximately 10 years, 12 years still remaining. In such cases, we have to file a patent for such inventions, and that is a credible job we can have. Then why we have to go for patent? So typically when we are comparing with the journal publication, patent gives royalty, patent give licensing, and in terms it added in terms of monetary incentives. Then market value, definitely we are having a patent, we can have a good market potential when we are having. Then commercial benefits, typically it gives us a overage in terms of commercial angle. So role of IP person in pharma industry, what we are talking about, and it is applicable for everyone. So patent filing, drafting, then prosecution for across the globe we can go for. So typically for having a mastery over few languages, say for example Chinese language, uh, or typically the German or the French, we can go for our own system where we can filing or drafting and prosecution across the globe. Then infringement analysis is typically a new area where we can work. So where our inventions or our inventors, whatever the said invention is having infringement with the current patents or already granted patents or not, something like that. Then it also supports to R&D, where it saves the time for the research and development department. Then typically selection of new projects. So if any patent is already granted and if we are trying to start with a new project, we can have a patent analysis first, and then we can start with. Then career options as a patent attorney, if we are trying to have. So typically, independently, we can practice patent law, being a consultant to several companies. Just like us, we are having our client base all over the world, and we are filing across the globe for different our companies or clients. Then we can have as an advisor to the corporates in the matters of intellectual property. And then we can join a law firm as a patent agent or a technology specialist. And for such thing, we don't require to have a law background. If we are having a law background along with the science or typically the bachelor's degree in technology or science and technology, it's quite beneficial. But if you are not having a law background, still we can act as a we can join or we can assist the firm in terms of patent agent or technology specialist. Then there are different things what we can pursue as a patent attorney or patent agent. And typically, so we can join as academician in the universities or institute teaching patent law, or assisting many new budding scientists to motivate them, to assist them, or escalate the total or uplifting the intellectual property within the university. And typically it is going to get added with our nation's intellectual property. So we can join as a patent examiner or patent analyst with the IP offices, which is like a government job if we are trying to seek for a safe or challenging job, then it is about the patent examiner or patent analyst job. So today patent agent qualification is considered as a professional practicing career we can have. Patent agents are employed in the most of the corporates having R&D background to check inventions, develop infringement activities of their routine procedures. So if we can have such type of qualifications, or if we are qualifying the patent agent exam and we are trying to pursue our career as a patent agent, we are having many opportunities to work on. And I think so. After a bachelor's degree, if we are having a patent agent qualification with us, and if you are joining any company or any firm, uh, typically, if you are saying in terms of package, so 2 to 3 lakhs per annum will get added to your package. Uh, it is a very common thing, and it is like most of the companies prefer to have patent agent qualifications along with the technical expert side. Most of the MNCs preferred R&D employees with certified patent agent. We have already discussed. So most of the organization established for research will prefer and impart prominence to the certified patent agents and consider their reports as authentic because you all are aware about the typical day to day when we are dealing with the share market, and most of the mergers or the companies are getting their shares on upside or downside, and most of the time it is based on their IP portfolio. It is as far as concerned with the pharma. And you are having a classic example, if you know about the Daiichi company, which which has taken over Ranbaxy. So career revenue of a patent agent in terms of pharmaceutical chemical industries, information technology companies, biotechnology companies, automotive industries, electronics and electrical industries, aviation and space research organizations, research-based universities, and the defense services, typically DRDO, DRDL, and other defense research wings are trying to attract qualified patent agents. We are having a wide array of science background because uh, different projects from different backgrounds are preferred in case of defense services. And as far as the universities is concerned, most of the universities are trying to expand their portfolios with multifaceted or what we can say the multiple subject related areas. So agriculture, seed, fertilizers industries, these are also booming in terms of IP. And it is as far as said that up to 2030, if we are not aware about the IP in terms of agriculture or seed or fertilizer industry, we will vanish our original or natural seeds. So Indian government has launched a new program where they are identifying the original or native seeds, and they are trying to protect it with IP. So IP facilitation centers like TIFAC and SIST, TNT, DPC, NIF. So there are many facilitation centers governed by the government of India where we can have our career. Legal outsourcing companies, knowledge processing centers, law firms, corporate law firms we can work on. Then patent search organizations. So it is like a private one. Government institutes like CSIR, CCMBs, where we can work as a patent agent. International bodies like World Intellectual Property Organizations and other UN bodies. So where we can work as a attorney, or we can have Indian Patent Office. There are many uh, vacancies in Indian Patent Office as an examiner or different positions. So role of patent agent, practice with the patent office in India, which we can work on. Prepare all documents, what exactly the role of our patent agent. Then transactions related with the filing of patents. Then discharge the functions in connection with any proceedings. Say, for example, if there is a pre-grant oppositions where any person in interest has raised a opposition for your inventions, then in such case, you can act as a lawyer and you can work with the proceedings of the patent office in terms of whether the invention is non-infringing or likewise. Then it is eligible to apply for patents and obtaining patents in India or elsewhere. Authorized to prepare specifications of the patents or other documents relating to patent prosecution. Authorized to provide opinion on the validity of patents, patentability of the inventions or infringement matters. So who can practice? So registered patent agent, normally called as attorneys, are only people authorized to practice patent law. So for filing a patent in India, we typically don't require patent agents, but if we are taking help of registered patent agent, it is very much easy to file a patent in the form of specifications given by the patent office. But to be honest, in India, if we want to file a patent, there is no need to have patent agent qualifications. Any person can file a patent in India. So requirement of patent agent. So citizen of India, it must be completed the age of 21, has obtained a degree in science, engineering or technology from Indian universities only, and has passed the patent agent qualifying examination conducted by the government of India. So when we are working in the patent area, so at least a graduate from technical background, engineering, pharmaceutical, biotechnology or food technology and etc. fields. So very strong technical knowledge is required when we are acting as a patent agent or we are facilitating the process of patent filing or thing. Postgraduate or PhDs are preferred because they are having a wide area or typically they are trying to address that the basic background to file a patent. Uh, Basically, it is requires understanding of the technical field. And if you are having the post graduation or PhD in such field, you can understand the invention in a well defined manner. You can understand the invention. You can file the boundaries, legal boundaries around that invention so that you can use that invention for filing a patent. So doing a postgraduate diploma course in patent law is added advantage, but it is not mandatory one. So, and typically patience and interest to read is likely requirement of to pursue a career in patent. Then different courses are available in India, like a postgraduate diploma course in patent law is available at Nalsar, Hyderabad, a National Law School of India University, Bangalore. Then Indira Gandhi National Open University. Then patent examination is conducted by the patent office, and frequency it is not exactly fixed that, but once a year it happens. Already in the current month, it was there. Then authorized to file a patent on the behalf of the inventor. Then bachelor's of law. So this was like actually related with the exactly what is the patent and how to file a patent and all those. But basic requirement to file a patent is an idea, and what exactly the idea is when we are saying uh, how to identify an idea or how to initiate an idea, we have to ask the right questions and innovate with strong focus on your users. So this is our typical questionnaire when we are dealing with any inventions, we always try to ask the right questions. We have to then we have to innovate with the strong focus on the your users, their needs, and your insights about them when we are having any problem with us. And we try to analyze what exactly the user or the person wants to have. Say, for example, if we are having we are trying to uh, develop a solution for any problem, we have to ask, or we have to strong uh, focus on the user requirements. Then we have to take some steps which are beyond the obvious solutions, and therefore increases the innovation potential of your solution. And typically we have to like bring together perspectives and strengths of your members so that it will ideate in proper manner, and which will uncover the unexpected areas of innovation. And it is like the team activity where we are trying to give some challenges, and we are trying to always, it's like unexpected areas of innovations which gets uncovered, and which creates a volume and variety in your innovation options. So whenever we are having an idea and we are trying to expand that idea in terms of innovation options, so always try to discuss some ideas, whatever you are having. It may be a simple idea for you, but when you are discussing with your team members, and it comes with different options in different dimensions even. So why do we need ideation in design making? So which challenges obvious things, and which creates a great progress in terms of inventions, I will say. So we will start with the great applying ideation methods. So typically we have to emphasize what exactly the problem is. Then we have to define our point of view, and then we have to ideate. So, ideation is typically the thing we always say no. In India, we are not having ideas, or we are not having such a brain. Whatever the brain we are having, it is already there, or it requires lot of money to go for inventions. So, actually, our story starts with uh, 2016. You have got to know that in 2016, approximately in the January month, uh, there was a terror attack at our Pathankot air base. And you might have know that we have lost our many soldiers in that terror attack. And after few days, it there was a news in Hindustan Times that the Pathankot Air Base, which holds our, it is a premier air base, which where we are having our aircrafts are there, the premier aircrafts are stored there. It is not having a fence, properly fence. And it is not the case that we are not having money, or Indian government is not providing money to have a phase for premier air base. So can you imagine that it is not the case with the, it is not case with, we are not having money, but our, we are trying to. So it is not the case. After few days, again, there was a news that we have returned 37,000 crore rupees from the defense ministry, which was unutilized. So it is not case we can say that we are not having money to build the fence. So simply in India, we are having our attitude that only and only if we are having money, then and then only we are having inventions. So it is not the case. So you will say Indian government waste food worth of approximately 14 billion a year, and typically 194 million Indians goes hungry daily. So on one side, we are wasting our food, which is worth of approximately 14 billion, due to we are not having containers to store the excess grains which are or crops which are already covered. And on the other side, we are having typically a number of 194 million Indians goes hungry daily. So only thing, it is a simple challenge that we are not having containers to store. How we can deal with such a problem? So such type of issues are there. So in India, so you will say it is happening only in India. So can you imagine the building? So it is a Pentagon, and you already have heard that it is the world's largest security network related things. It holds the security, highest security network all over the world. And it can't be breached according to the reports. But even you have heard the name of Edward Snowden, who uh, have disrupted the total security system of Pentagon and trail out the important documents or security documents from that, and it given to the Al Qaeda and all those terror groups. And after that, what happened? The 9/11 attack was there, and everything was there. So it is not the case only about the India; it is all over the world. It is in case of America also. So what we have to develop, we have to change our mindset from these are like a typical things. We are not having the money, we are not having the infrastructure or the network. No, it's not possible. We have to change our attitude. We are living in 2025, and we have to change our attitude from the complex to complicated thought process. So when we are having the ideation, and it is typically when we are trying to aware about the intellectual property, it is always and always a question about we are living in the new age of artificial intelligence 2.0, where everything is like now it is not about the complexity, it is about the complicatedness. So we have to change our attitude in in case of ideation, or when we are having the innovation in terms of new things. So when we are having a game of snooker, you can game of chess, where you can predict what will be the end result, because you can have some permutation combinations and you can predict what exactly the, because the it may be around the 64 lakh steps or moves maybe, but you can predict it out. But when it terms, when you are having such a game like a snooker, where a world class player even can't predict what will be the next shot, or he can't repeat uh, the shot or the opening shot of that game. So when you are now dealing with the ideation, and when we are having such examples as the Apple company, and Apple is typically a company which deals with the innovation, really. It is not about the gadgets. They are related with the innovations. They are pioneer in the technology which for the innovation. And typically, if you have seen the advertisements of the Apple, they have never talk about what exactly the processor speed, what exactly their memory. They are not focusing up about their camera quality or camera, what exactly the megapixel may be. But no, they have never. They have talk about the security. They have talk about the beautifulness. They have talk about the quality. And when it comes with the comparison or competitiveness, you can't beat quality. You can't beat beautifulness. So what that exactly the luxury product, Apple product is concerned. So typically we are having the three types of diseases when we are having the ideation or idea or innovation attitude, what we can say. The first is about the arthritis, second is all about the coronary artery disease, and third is about the Alzheimer's. When we are talking about the arthritis, it is typically, if you are having arthritis, it is unable to move. You want to move, but it is unable, you are unable to move because you are having a lot of pain, and due to that pain, you can't move on. Second one is coronary artery sclerosis, or where your arteries are hardened and it is unable to flow the blood to heart towards the heart. And third one is Alzheimer's, where everything is like, okay, it's like disappearing, or dementia, what we can always say. Everything is getting okay, fine, likewise. So when we are saying the arthritis, and when you are, if anyone from the audience, if they have filed an invention, it happens always. Say, for example, you are having a concept and you try to develop that concept or that idea. When you complete with your specifications, your claims, and you just approach to the patent office for filing a patent, uh, before that only, you will find, when you are going for patent analysis, already filed patents, you have to go for the analysis, and you just uh, get notices that already Chinese inventor have already filed it. So you have taken approximately 1 year to file a patent, and within that 1 year, Chinese or say German, say or American person has already filed that patent. And in case of India, we are having a system of first to invent, but rest of the world, most of the countries follow a system first to file. So patent is granted for first to file. In India, we are having a process that we are filing a patent, and who is having the invention or inventorship, he will get a patent. So it is the same case that that is a super tanker carrying oil from one place to another in the deep sea, and one person who is on the board, who is like having a role to observe whether there is iceberg or not, and uh, the ship or the super tanker is sailing in the sea. Eventually, one iceberg is there, and the person who is on the board or on the ship notices that yes, there is an iceberg. He gives his information, or he translates his information to his superior. Okay, the superior translates his information to the super senior, and up to that, the distance between the ship and the iceberg gets closer and closer and closer, and the time required to get off the iceberg is remaining very, very less and less. And suddenly, after a process of different steps, finally a decision is taken to turn the ship on the right side, and eventually the speed has to slow down, and it has to get into the right direction. It requires a lot of consumption of oil to turn it high, on the right side. So similar case happens with us when we are having an idea, and we always say, don't try to uh, deepen that idea. Try to file a provisional application first, and then try to discuss those ideas, and try to get expand with the views of that inventions later on. So we always say, and in India, we are having a natural fear that someone with whom we are sharing our ideas will go and file a patent. And many times in institutes or in organizations, it is already a common, what we never say it like a threat, but it's a common fear that a person who is having idea never shares his idea with the colleague or some uh, another department. But we always say it is a like a arthritic situation happens, and eventually the inventions remains with the person only. We always say if you are having a speed of trust, you can collaborate with the departments or another person who is having the expertise in expanding your views of invention. Try to be with the thing. So it is requirement rather, because otherwise your invention will have a narrow dimension, and there are chances of uh, your patent or your invention will not have grant because of lack of innovative steps. So it is in, I think so, in the year of, I think so, 1970, in the jungles or the South Africa, there was a herd of elephants, and it was like outnumbered, uh, and from there forest department, it was decided to reduce the number of elephants, and it was decided to cluttered the elephants so that the number will get shrunken down because of the scarcity of water and food. So according to the members of a forest department, it was decided to cut down the elder elephants, so who were like older ones and weak, and the decision was taken to cut down the older elephants. And what happened exactly? After a year, the alpha males were there, alpha elephants were there, and already elder ones were gone. Alpha males were there. There were no elephants to guide uh, the uh, the crowd of elephants for the water in case of drought areas. So it is always and always you have to take help of your senior ones or who are having the expertise, because though they are not able to have inventions at their own, but you can always have help from how to proceed with your invention, or how to complete your experimental data in a correct manner. So what we always say, for your own thought process, the leadership should be from the authoritative, which is typically type of military type of authoritative leadership, to the coaching type of, and to exactly for the gardener leadership. Because in case of authoritative leadership, we always think about like a military, where exactly you have to follow the orders. So if order is there, you have to turn right, you have to turn right by the 45 degrees. So there is no like 45.5 or 44.4. No, it is not there. It is something like a straight one there. So authoritative leadership is not uh, good, or it is not possible for your invention, or as far as the patent cases are concerned. Then if you are trying to have the coaching leadership, so I will give a classic example of the legendary cricketer Sachin Tendulkar, who is having his guru Ramakant Achrekar sir. And Ramakant Achrekar sir has not even played international cricket, not for a single. He has, I think so, he has only played for a Ranji, and but he has created, or he guided Sachin Tendulkar in such a way that he created a legend in case of when we are talking about the cricket. So that is type of coaching leadership is also required when you are trying to. But exactly for the today's world, what we have to have gardener leadership, where like So we always say gardener leadership is something like that. We are having a plant of cactus and we are plant of rose, and we are watering the same way. We are doing manuring the same way. Everything is same, but we can't expect cactus to have flowers like roses. We can't say like, "Arey cactus, you are like." मैं तुमको वही सब देता हूँ, but you are not producing something, you are not performing well, we have to like cut down. No, it's not the way we have to look out. So whenever we are having ideas, don't treat it in such a way that only the glamorous ideas will go for the inventions or like that. Definitely you go for whatever the ideas you are having, go for the patent application. So exactly, the future leaders need critical future skills because, as I already said, we are the followers of Saraswati to Lakshmi approach. We are dealing with, whenever you are having intellectual property, it will be beneficial or it will be valuable only and only case if you are having money and you can make money with the intellectual property. That's what leading without authority. You should not have authority. Still, you have to go for filing inventions, creating a shared reality. You have to create a shared reality in terms of inventions that only uh, previously up to 2010, in case of pharma, I will like to say, there were only nanotechnology related projects were getting finance from the authorities, getting funding from the different regulatory authorities. But nowadays, it's not feasible to have a nanotechnology at commercial scale. So that is the reality we have to check out. Then psychologically safe environment must be created. So I think so in audience, there are many academicians or many stakeholders from the different areas. So psychologically safe environment is very necessary because IP system in India is a very uh, in a very nuisance stage. So I will say to culture it, I will say to have uh, psychologically safe environment is must. Then design and thinking and behavioral science. So we have to give freedom, or we have to create such an environment where students or the staff assistants will have uh, design or thinking freedom. So when we are having such examples from the Mahindra, so it is a car of from the Mahindra and Mahindra group, which is like a Scorpio. Uh, Before 2004, in India, we were having uh, jeeps were there, having terry cans were there, and it's like open hood jeep having a round or typically spare wheel on the back side, and it was like a macho looking vehicle, and each and every person who are having is a passion, they were always try to have such type of jeep and jeep there. So Mahindra and Mahindra company's design department decided to have to launch such a vehicle. So they designed a vehicle which were having empty shell, empty wheel cover on the back side to fulfill the need of spare wheel on the back side, but it was empty because according to design's law or the perfect balancing thing or security purpose, the spare vehicle has to be in between the rear wheels. So it has to be in terms of balancing. So the design expert says, no, we will go for a spare wheel, typical spare wheel on the lower side between the two rear wheels, and we will provide empty wheel case or wheel cover on the back side. The design case was of given for the approval to the Keshav Mahendra, who was the chairman of that department of the company. And he said, no, Mahindra will never have such things that andar se kuch aur, bahar se kuch aur. We will never have such things. So something like ethics has to be there when we are having innovation, because eventually it is going to fulfill the need of human mankind. So something inventions which are not exactly or which are misleading, we will never have. So if you want to have a thought process, have a thought process like a North Star. So then it is something like it is a marshmallow tower experiment. We always try to give such type of games to the students, and we try to analyze what exactly their team building capacity or their thought process. We try to identify, and such a project was given to the some group of students. So one group was from the kindergarten garden students, one from the architectures, and one from the MBA graduates, and one for the technical architectures, typically what we say. And after 15 minutes, it was like a surprise thing. Only kindergarten students were able to complete the marshmallow tower, and the MBA graduates, or what we always say, ki, architecture students or architecture graduates, technical persons were unable to even form a single marshmallow step. It is because of is always like we are having our thought process in a such a way that no, it's not my job, it's your job, likewise. Or other side is there, no, it's not my type of thing. But you have to start out with something, you have to apply whatever the idea you are having, and then only it's possible. So many times students fear to ask questions, or fear to express their views. They are having that someone will laugh, or such type of invention is not feasible even. Uh, so it's not the case. We have to share, we have to express our thoughts or ideas, at least to our mentors who can guide, and we can have beautiful inventions. So recently we have got inventions from the Andhra Pradesh. So where a student from he is from I think so BTech second year, and he has come up with a water filter uh, which filters out the heavy metals along with uh, so-called the bacteria and virus load also. And it cost approximately 5 paisa per liter. So can you imagine such an invention is possible? And so something like that, or we are having a design patent from in Sangli district, which is near to from Sakrade, and the students have developed a system which can be attached to a bullock cart, and in case of the season where the sugar canes were loaded on the bullock carts, and due to the load of that sugar cane, many times the bull is unable to carry the load, or sometimes the death of that animal may happen. So he has developed such a system with a simple tire and the shock absorber system, which will get applied between the uh, two bulls, and it's like a life saving for that bulls, also for that farmer who is investing a huge amount. So such type of inventions are there, and we have to recognize such a potential or such type of solutions coming from the students also. And it is a simple solutions. I don't think so it requires like rocket science things or to develop such. So so when we are dealing with inventions or solutions from different backgrounds, so it is like a simple story we always give in our presentation, that seven blind person were there from birth, and elephant was placed before them, and were asked to identify what exactly elephant look like. According to one, it's like a fan, it's like a spear, it's like a snake, it's like a tree. But uh, are they perfectly wrong in their description? So some of you will definitely say, yes, they are wrong. But according to the science or according to the invention background, when we are having our perspective, it is always and always right. So whatever we are perceiving, it is always right. It is not necessary to identify elephant in such definitions. You can define your own inventions in a particular way, and patent office is having leverage to grant your patent, but you have to justify that yes, it is having a novelty, it is non-obvious, and it will have industrial application, and if the patent will get grant. So what we are trying to already, I'm again and again saying that I am Lakshmi follower, and having a Saraswati base, Lakshmi will follow. So we always see money, how the money will be coming. So during, basically I'm from the pharma background, so I'm trying to give examples from the pharma only. So during Corona uh, era, so we were having a lot of demand from the world about the herbs or herbal products or organic products. And it is like having a good demand when we are having a report card, something like that, we can see. So we are trying to look out for exactly what we can check out from the international market. And it's you can imagine the figures are in 1790 crore market potential is there, and stated the figures are from the 2016-17. If you are looking at how it is getting, so each and every family is trying to have their health supplements, then OTC products, ethical or digestive or different types of, or say cosmetics are there. So the world is getting attracted towards the herbs or organic products or uh, handmade products likewise. So we have catch that thing, and different products we are trying to cover that from different, the cosmetics definitely from the natural background. Then we are having different supplements. So actually what we are trying to address here is that a typical or traditional path for research is by the researcher in the institutional lab only, and definitely for the publication in high impact factor journal. But what we required is by the researcher in institutional lab along with the collaboration with industry, and definitely it has to serve the society. Uh, at in the year 2019, in case of CSR awards were there, and the first prize was given to a invention where the student have developed a ring, what we can say, we always like finger ring, what we always uh, the ring was developed in such a way that it will reflect the hemoglobin of that person who is wearing that ring. Can you imagine, without isolating or without rupturing the skin, the ring is showing the hemoglobin of that person, which is like a simplest technique in rural areas or where it is not possible to go and have that sample for the pathological purpose and getting checked with the hemoglobin and try to identify, yes, such type of medicine must be given. No, it's not possible because there are such remote areas where not even roads are there or not even a facility to store that blood sample and which can be carried to the, in such things. And I think so it was based on some IR technique, infrared radiations were involved in that technique, and simple ring has to put on the finger of that person, and it will give 99.99% accurate hemoglobin. Such type of inventions must be there. So the thing is, so it's like a paradigm shift, what we always say, and due to some challenges, we have decided to work on different novel things. I will skip this area. So typically this is type of inventions what we have developed. So it is like a bindi, and this bindi contains required vitamins in them. So in India, it is like a tradition to use bindi, and we have incorporated all the vitamins which are required for the that lady or that patient, and it will get absorbed through the skin. No need to drink it or swallow it, or that the typical smell or that taste of that multivitamin, which is like a obnoxious odor are there. So it's not there. It is simply you have to put it on your forehead, or we have developed some tattoos along with the bindi shape. So it can be incorporated on any skin part, and it will get absorbed. We have also developed iodine containing bindi. So in India, most of the ladies are deficient of iodine, and we have given such a formulation the government of India, and it is available in the government hospitals, and it is delivered to the patients who are having on the iodine treatment because of hypothyroidism. Cases are many in India. So in terms of that, we are providing some solutions in novel formulations. So it requires hardly 30 paisa per bindi, and the whole multivitamins will be inside the blood. So we have developed some novel technologies for the fermentation point of view. So we have come up with novel fermentation techniques. So you have already heard about the vinegar and all those formulations. And we have, it is an ancient old technology, but we have transcripted that knowledge into the modern sciences, and we have developed the cultures of that bacteria in such a way that it will be utilized for generation to generations, with giving the same exact composition of vinegar. Then we are having some patented formulations, and somewhere we are having a patent for our packaging system. Somewhere we are having our patent for the process of preparing that formulations. Likewise. Then we are having a coconut sugar. We have a patented process to produce coconut sugar. So already we are having a jaggery in the market. We are having brown sugars in market. We are having a palm jaggery in the market. But we were never having the coconut sugar. But right now we have developed a technology in such a way that it will produce coconut sugar, and it is perfectly the solution or alternative to the natural sweetener. Then we are having some formulations for different disorders. Then we are having a classic example. Typically we are having film which will incorporating medicaments. We have to just place that film on our tongue, and whatever the medicaments will get absorbed. Can you think that in case of children, what will happen? And giving a medicine to a children is like a cumbersome job. So it is like a typically a challenge to give medicine. And we have developed a technology where we are having a number of characters from the Marvel Studios, and we have developed that formulation, and we are giving, say, simple paracetamol, and we have incorporated in the film, and film has to be placed on. And most of our formulations have organic based taste from the fruits. Different fruits are there, so we have developed that even the taste formulation also. So typically it incorporates so vitamin A, vitamin B complexes, vitamin C, vitamin D3. So we have developed this tropical berries flavor in the organic format. We have also developed formulations like many time it happens that physicians prescribes 5 to 6 medicines, and you have to take one by one, and you have to drink approximately a liter of water. What will happen if we are giving you a single capsule which incorporates your all 5 to 6 medicines in one capsule only, and you will like say yes, it's possible, and it's like a quite uh, advancement in the pharmaceutical sector. We have developed the slow formulations, so we have incorporated all the medicines in one capsule only, and it will get slowly released as per the time schedule. So these are our some images from the users or clients. So this is typically we are having. Then we have developed, this formulation, we are having our patent in case of, this is like a oil-filled capsule, and it is sealed with a band. And this band has developed by a chemical engineer who have given us a simple solution which gives a sealant activity for such type of capsule. So it is like a normal capsule, but we have developed it into modern medicine with. So this is all about what we are having. We are having an innovation through natural ways, research based only, and only for the sustainability of. So knowing is not enough, we must apply. Willing is not enough, we must do. Thank you. Thank you so much. On the behalf of Dr. Gildas Nutrition, I would like to thank the organizers for giving me opportunity to share my views. And definitely, we have just started, and I'm also a student of science, and still I'm working on to make different technologies. Thank you so much. So if there are any suggestions are there, because I am not expert in the field. I am a still student of the field. Last 20 years, I am just still studying different areas of science and still working on. So if I have any suggestions, please let me know. So here is my contact details. You can mail me. That will be the great thing for me. Thank you. Thank you so much.
Thank you, sir, for your wonderful and informative session regarding IPR, patent, innovation, ideation, invention, etc. I really thanks for sharing your knowledge on the topic innovation trends in renewable energy and sustainability. Now we move to the question answer session. Participants are requested to ask the questions. Now forum is open for discussion. Any questions from the participants? Please ask.
Hello, sir.
Hello.
Uh, Good evening, sir. Dr. Deepak here from D.Y. Patil Medical College, Kolhapur.
Good evening,
Hello.
sir. Bola.
Ha.
Yes.
Ha. Sir, your presentation is very nice. I have
Thank
a
you so
small
much.
question regarding the hemoglobin detection method
Okay.
by simply wearing the rings. So,
Yeah.
may I know more details about that? Is it feasible for point of care device in tertiary healthcare center? Because we have developed here so many
Definitely.
methods.
Yes. Yes. Definitely, sir. Yeah, it was the invention was published in the CSIR award ceremony.
Okay.
And I will try to get those details from the CSR office. Definitely, Raghunath Mashalkar sir is there, and I will
Okay.
ask him to share the
Yes.
details with me, and I will
Okay.
request him rather to share the details. And I will, if you can drop me a mail on my
Yes.
email ID
Sure.
so that I can share those details with you.
Because very useful for that by school level hemoglobin camps, only one detection level.
Definitely, sir. Definitely.
Okay. Thank
Definitely.
you.
And it's like a good appreciating efforts you will take.
Yes.
Yes,
Sure,
sir.
sir. Thank you, sir.
Thank you, sir.
Yes, dear participants, is there any questions from your side? Please ask. Now I think questions are over.
Yes.
Thank you, participants, for your questions, which lead to a fruitful discussion. Now, dear participant, the feedback link will be shared in a chat box. Please fill it immediately. We end the third session of today's FDP. I extend heartfelt thanks towards our guest speaker, Dr. Suhit Gilda sir, for sharing his knowledge. Thank you, sir. Now, I hand over the mic to Dr. Umakanta Jadhav sir. Jadhav sir, please.
Thank you, ma'am.
Thank
you for the nice comparing, and thank you to the resource person.
Thank you, sir.
Let us take a break for 5 minutes. And after the 5 minutes, we will resume for the valedictory function. I request all the participants. After 5 minutes, we will start our today's valedictory session. This will be the last session of today. And take a break of 5 minutes, and we'll once again gather here for the valedictory session. Thank you.
Zukari sir, make me co-host.
Okay, ma'am. Just a minute.
Zokare sir, even add others also if Mithun sir and others are there. So add them also. All those who are now in the valedictory session. UK sir, you are the only anchor or anyone is accompanying
No,
you?
sir, I'm the only anchor.
Okay, okay, sir. Okay.
But Mithun sir will address, and Sita
yes.
madam's requirement is there.
Okay, sir. Okay.
Yes.
Ubala
yes.
ma'am, are you there?
Yes, sir.
Ma'am, I'm unable to find your name.
1, 2, 3, 4, 5, 6.
1 minute. I have joined like.
Ma'am,
Okay,
you
I
need
will
to
just
rename. It is
rename.
bearing the name 1, 2, 3, 4, 5, 6.
Yes, yes.
Ma'am, now you are the co-host.
Okay. बोला ना. Zokare sir.
Yes, ma'am.
Mithun sir had joined. You just make him co-host.
Yes, ma'am. Mithun sir is already co-host.
Okay. Am I audible, madam? Sir? Doble sir?
Yes, sir.
Good evening, sir. You are audible.
Good evening, sir. Just I came.
Jadhav sir,
Yes, ma'am.
shall we start?
Yes, ma'am. No issue. Good evening, everyone. I, Dr. Umakant Jadhav, extend a warm and heartfelt virtual welcome to the valedictory session of the AICT's ATAL FDP on From Ideas to Innovation, a patent landscape approach to science and technology correlations. Today, we conclude this enriching 6-day journey started from 22nd January to 28th January 2025. We celebrated the immense learning, valuable insights, and the collaborative efforts that made this program a resounding success. This program was proudly conducted by Nagesh Karajgi, Orchid College of Engineering and Technology, Solapur, in association with ATAL Academy, which operates under the esteemed AICTE New Delhi. The collective efforts of these institutions have provided us with a unique platform to explore, learn, and innovate in the domain of patents and technology correlations. Today, we have with us for the valedictory session, Honorable Principal of Nagesh Karajgi Orchid College of Engineering and Technology, Dr. B.K. Songe sir, respected Vice Principal, Career Development, Honorable Dr. Srinivas Methan sir, respected Vice Principal, Admin and Academics, Honorable Dr. V.K. Patki sir, Dean Research and Development, Dr. S.S. Jagirdar sir, First Year HOD, Professor S.D. Jadhav sir, Coordinator of the FDP, Dr. P.A. Ubale Madam, Co-Coordinator for this event, Dr. A.V. Sadapurkar Madam, and my dear participants member. To formally commence our proceedings, it is my privilege to invite our Vice Principal, Dr. Srinivas Methan sir, to share his thoughts and reflections on this program. Sir, the virtual floor is yours. Over to you, sir.
Okay, am I audible?
Yes, sir, you're audible and you're absolutely visible, sir.
Okay, thank you. Thank you so much, Dr. Umakant.
Yes.
Actually, this is a concluding session, and rather than you can say the role of a concluder, I am very much happy to state you that I was a participant for last 5 days. Today only I had missed one session, and then I had joined the last session. So good evening, esteemed faculty members, industry persons, participants, organizer, and distinguished guest. It is truly an honor to address this gathering at the conclusion of faculty development program, which is a very unique one, from ideas to innovation, a patent landscape approach to science and technology correlation. So each and every aspects of patent is covered in this particular, you can say, program only. I think over the few past days, you have collectively explored the fascinating interactions of ideas, innovation, and the critical role of patents in driving scientific and technological process. This program has been a unique opportunity to not only gain knowledge, but also to exchange ideas and perspective on how research can create impactful solution for the society, ultimately to the state, to the, you can say, nation. This journey from idea to innovation is rarely linear, I think so. It is often a winding path of with a lot of challenges. Patent plays a critical role in fostering innovation by protecting the intellectual property and encouraging researchers to push the boundaries of what it is possible. I think by leveraging this particular gap with a strong correlation between the research and the, you can say, practicalities of the patents, we can very easily bridge the gap between the academic endeavors and industrial applications. This faculty has undoubtedly provided a robust platform, right? I think the methodology of effectively utilizing the patents strategies to encourage multidisciplinary approach and research insight into the global innovation ecosystem. Why I'm saying global? Because there are some, you can say, participants even from Iran, and some, you can say, the researchers or some inventors were also given us input from the abroad countries. And before I conclude, let me take a moment to express my heartfelt gratitude to the organizer of this program for their vision, dedication. Right? A special thanks to all the resource persons and experts who shared their invaluable knowledge and experience. And one more thing I can add here, that the enthusiasm of the participant, right? Because I was also one of the participant, engagement, commitment of the participant has driven this particular, you can say, FDP to a next level, that is the highest level. And again, the torchbearer, whosoever is the organizer is there, right? They have very systematically planned and executed this particular program with a very brighter and sustainable for the sustainable future. In the words of greatest innovator, I heard from in this particular session only, Thomas Edison sentence, some of the, you can say, innovator has explained about, the value of an idea lies in using of it. So you're supposed to use your ideas. That is what the, you can say, Thomas Edison has stated. So let us ensure that whatever ideas you might have generated during this particular course of 6 days program, you may utilize it for, you can say, use it for definitely meaningful, innovative transformation of the common man and human being. So thank you. But before that, I want to just add some of the things as a, you can say, participant, that day one, that Dr. Vidya Rani Kshirsagar ma'am has very brilliantly explained about how to balance the you can say, protection, innovation, and public access. And I like one of the session on the second day only, development of nano biotechnological tools by Dr. you can say Shesharth Bhosle sir, right? And there were a lot of inputs we got as, you can say, the researcher or as a faculty member to give the problem definition to our student. Kalyani Ahirman's patent landscape was again one of the, you can say, key discussion which has happened on this particular platform. Dr. Shivkumar Shivpuje, a patent landscape, he discussed and analyzed actually the biotechnology he discussed about. And that was again one of the very important, and from the pharmaceutical perspective. Then Dr. Padmakar Kelkar sir, right, patent a case study. All these, whosoever has given the, you can say, delivery on in this particular platform, really it was worth to sit and you can say explore those. Last but not the least, as rightly pointed out by Umakant Jadhav sir, we are Nagesh Karasgi Orchid College of Engineering Technology, Solapur. Thank to AICT and all of you, because we have been NAC accredited A+ institute and one of the renowned research institute in our area, where more than 50 patents have been, you can say, published by our faculty members from our organization. Around 4.5 crore fundings have been used, you can utilize for the, you can say, development for the rural ecosystem as well as the urban ecosystem. So from that particular background, we are working further hard to get, you can say, this innovation mindset in our campus and in our society, in our state and in our India. And there were some participants, there were around 10 state participants who have present in this particular FDP. More than 230 participants daily, they were present. So it is a huge success to all the organizers and all the FDP. Thanks to AICT for giving this opportunity to Orchid Engineering College. Thank you. Thank you all.
Thank you so much, sir, for your inspiring words and valuable insights. Your encouragement truly motivates us to carry forward the spirit of innovation. As Ralph Waldo Emerson rightly said, the mind once stretched by a new idea, the mind once stretched by a new idea never returns to its original dimension. This FDP has indeed broadened and perspectives and equipped us with the mindset of innovation. Let us move towards the experience sharing by our participant. It is said that a program success is best reflected in the experiences of its participants. Let us hear from you, our participants, about your experience and a key takeaways from this FDP. I invite those who would like to share to raise their virtual hand and use the chat box to indicate your interest. And kindly unmute yourself and share your reflections of this 6 days
Good evening,
FDP.
sir. Good evening, sir.
Yes, ma'am. Yes, good evening, ma'am.
Good evening, sir. I am Dr. Megha Kothawde from Guru Govind Singh College of Engineering, Nasik. It is very precious to talk in front of you. This FDP is really valuable for me because there is a lot of information that we have got, lot of knowledge we have got in through this FDP. Thank you so much, sir. And in future also, we are expecting that you will organize such FDPs.
Thank you, ma'am, for your time.
Thank you, sir.
Yes.
Thank you.
Yes.
Good afternoon. Myself, Professor Shubhangi Kashir from
Yes, ma'am.
ATAL College. All the sessions in the FDP were very good and relevant. All resource persons gave practical real-life examples to explain the concept. Also, they explained the detailed procedure of patent filing. Thank you to organizers and resource persons.
Thank you so much, ma'am, for your kind words.
Sir, let them on the video, please.
Okay.
Perfect.
Yes, ma'am. We'll ask. I ask all the participants, please turn on your camera while giving the feedback.
Good
Yes.
evening, sir.
Good evening, sir.
It's Abid Makandar, Assistant Professor, Department of Mechanical Engineering, Big C,
Yes,
Solapur. I would like to express my I would like to express the thoughts and feedback on the 6-day FDP workshop on from ideas to innovation. I just want to appreciate the opportunity to reflect the experience. First of all, I would like to express my gratitude to the organizing committee, sir, and the facilitators for putting together such a valuable FDP. It's clear that a lot of thoughts and efforts went into creating this experience. First of all, I just want to start with the content of the FDP. I might take a bit time, sir. Pardon me if it is affects. So I just want to talk about the content, which was very much aligned with the goals of the FDP. It addressed the current trends as well as the need in the education, research, and faculty development. Even though the FDP was conducted by the Basic Science Department, the topic had a broad window which led to the faculty of various fields to participate in the workshop. The content of the FDP was comprehensive and well structured, providing valuable insights, and further extending my gratitude to the resource persons talking about the different sessions. About the session, the resource persons were very much knowledgeable and experienced in their respective fields. And when I want to talk about the experience, then obviously Dr. S.H. Pawar, sir, he just made a remarkable contribution across various fields, and we are really happy to listen to his research work as well as in the different fields, in the medical as well as the engineering. His dedication and passion truly inspired us inspired us like us research scholars like us. And one more, I just want to acknowledge another speaker, Dr. Vijay Kumar Shivpuje, for his inspiring session. The structure and delivery were exceptional, making it one of the most reward learning experience I have had. His clear, engaging explanation allowed us to connect deeply with the material, which made the session particularly memorable. And lastly, the session was really well scheduled, ensuring it didn't affect the work hours, or else attending 6-day long FDP offline, that really wasn't possible. And the time schedule that was maintained was really good. So after the working hours, we came to the home and we attended this. And I just want to extend my thanks to the conveyors, Dr. Panchashila Ubade and Dr. Sadlapurkar. Dr. Panchashila Ubade, ma'am, your leadership in stressing the entire team is truly commendable, ma'am. This is a true example of what women empowerment means. Thank you, sir. Thank you for allowing this opportunity.
Thank you so much, sir. Next.
Good evening, sir. Hello.
Hello.
Good evening. Good evening, sir.
Yes, good evening, sir.
I'm Dr. Vagish speaking.
Yes.
From FabTech Technical Campus, Sangoda. The ATAL FDP was extremely organized extremely nicely, and all the sessions were very nice, and we could get a lot of inputs, and I expect similar FDPs in the near future. And the earlier speaker has told everything about the FDP. I need not elaborate much again. Thank you very much, sir. Thank you.
Thank you. Thank you, sir.
Good evening, everyone. This is
Good
Alsaba
evening, ma'am.
Nadaf. This is Alsaba Nadaf from Walton College. I am a research scholar, and this workshop helped me a lot in my research. And I thank all the organizers for organizing such a wonderful and knowledgeful workshop for us. Thank you so much, sir.
Thank you. Thank you, ma'am. Yes, any other experience sharing from the participants? Your feedback.
Hello,
Hello.
myself Dr. Avtade ma'am from Sweri College of Engineering, Pandharpur.
Yes, ma'am.
I'm very much thankful to arranging such wonderful FDP. In this FDP, all sessions are very relevant and useful for professional growth also. And all speaker provide very sufficient information along with many examples. Thank you for organizing such a wonderful FDP. Thank you, sir.
Thank you. Thank you, Avtade ma'am.
Good evening, sir.
Good evening, sir.
This is Dr. Deepak Sawant from Diva Patil Medical College, Kolhapur.
Yes, sir.
This ATAL online 6-day faculty development program really well organized from the NKOCET College of Engineering. I think it is very, very beneficial for patent landscape and approach, and it is really we will learn so many knowledge from your relevant speakers. I will also thrust areas from other that I am really thankful for organizers, sir. Thank you very much, sir.
Thank you, sir. Thank you for your time.
Hello, sir.
Yes. Yes, you are audible, sir.
Good evening, sir.
Good evening,
Myself, Dr. Rajesh from JBRPC Pharmacy College.
Yes, sir.
Sir, I'd like to express my heartfelt thanks to NKOCET College of Engineering and Technology, Solapur, for conducting this ATAL FDP from idea to innovation, a patent landscape approach to science and technology correlations. Sir, I want to thank all the resource persons and all the organizers, and I would like to mention 3 points regarding the selection of the excellent resource persons and the excellent topics, and the most important one is participant friendly approach. I would like to thank all the organizers. Thank you so much, sir. Thank you.
Thank you, sir. Thank you for your kind words, sir.
Hello.
Hello, ma'am.
Hello. Good evening, sir.
Good evening, ma'am.
Good evening, my friends also. Actually, I'm here for expressing my feedback regarding this FDP. I'm Rohini Shankar Jangle from Sri Shivaji Mahavidyalaya, Barshi, Solapur. Basically, I would like to thanks to our principal who allow us to join this online FDP. And then second one, I would like to thanks to my friend, that is Dr. Sadlapurkar ma'am, as well as Dr. Ubade ma'am. They insist us to join this FDP, and because of joining this FDP, I got a lot of idea about the patent. Because I am the new in the research area, I am pursuing my PhD under Solapur University, and I don't know about what is meant by patent and how we have to file it. So because of this FDP, I got a new vision regarding the patent, under which area we could file like designs or maybe like new methods even. So due to this FDP, I got the knowledge about the patent filing as well as procedure for the patent filing. And whatever the resource person you were selected, really, sir, they all were very knowledgeable, and we got new ideas regarding in these areas. Basically, everyone knows the ideas in this area, but how that idea moves towards the patent, we know due to this FDP. So again, I would like to thanks to all your organizer team and ATAL. I may say that the AICT side that give the opportunities to join this FDP. Thank you, sir.
Thank you. Thank you, madam.
Hello, may I audible?
Yes, sir. You're audible, sir.
Sir, I'm Vishal Pandit from Sri Sadguru Gangagir Maharaj Science College, Kopargaon.
Yes, sir. Yes.
I'm very thankful to the organizer and team of the NK Orchid College of Engineering, Solapur. I particularly impressed by the speaker, Professor S.H. Pawar, sir. And all the speakers are a very interesting lecture series. I'm very much thankful to all the team once again. Thank you, sir.
Thank you, sir, for your time. Thank you.
Okay, this is again Dr. Srinivas Mithan. Just I wanted to state here one thing. There was one collaborator or one expert yesterday discussing, and one of the Iranian, you can say, participant has expressed his thought that why don't we can do the research, collaborative innovation, right? So I here express my view that NK Orchid College of Engineering Technology Solapur is ready to collaborate with whosoever want to collaborate with us, right? Because this is a new approach, and collaboration is one of the buzzwords where we can do a lot of innovations together, not only in the city or in the state or in the nation, but even abroad countries. So we are also doing it. If somebody is interested, please let us know through Ubade ma'am or to the organizer. Thank you.
Yes, sir.
Hello, sir.
Hello.
Hi, sir. I am Mr. Anmar from Iraq, and I had master on biochemistry. So it's really I'm so enjoying to participate on this season, and really it was incredible. And I enjoyed too much, really, for getting more information, and really I get a lot of notes help me on my research and give me some ideas about the research I'm working on. So and really it was my honor to participate in all of you, and thank you so much for this season, and And that's all, sir.
Thank you. Thank you so much
Thank
for
you,
your
sir.
experience sharing and your participation, sir. Thank you,
Thank you, sir.
on behalf of our organizing team. Thank you. Yes, Bali ma'am, shall we move further if no feedbacks are there?
Okay, sir. If no feedbacks are there, we will move to the next session.
Oh, okay. So thank you so much for sharing your thoughts. Your feedback reflects the impact of this program and motivates us to continue striving for the excellence. Before we go for the vote of thanks, there is announcement for the participants. You be there in the session because we are going to take group photos at the end. After the vote of thanks, formally completion of vote of thanks, we are going to take the group photos at the end. So participants are requested be there in the session till the last. To conclude this program, I would now like to invite Dr. Ashwini Sadlapurkar Madam, co-coordinator of this FDP, to deliver the vote of thanks. Ma'am, over to you.
Yes, sir. Am I audible?
Yes, ma'am, you are audible.
Good evening, everyone. I am Dr. Ashwini Sadlapurkar, co-coordinator of the AICT ATAL FDP on From Ideas to Innovation, a Patent Landscape Approach to Science and Technology Correlations. We are here today for valedictory function of this FDP. On behalf of Nagesh Karasgi Orchid College of Engineering and Technology, I extend my heartfelt thanks to ATAL FDP Director, Dr. Sunil Luthra, for providing us this opportunity to conduct 6 days online FDP. I am grateful to Prajna Niketan Education Society Trust, Honorable Management, Mr. Vilas Patil Sir, Mr. Ankush Chavan Sir, Mr. Mayuresh Bodke Sir, Honorable Principal, Dr. B.K. Songe Sir, respected Dr. S.S. Metan Sir, Vice Principal, Career Development, respected Dr. V.K. Patki Sir, Vice Principal, Admin and Academic Development, Dr. S.S. Jagirdar Sir, R&D Coordinator, Professor S.D. Jadhav, First Year HOD, as well as Dr. Panchashila Ubale, FDP Coordinator, for their continuous support. I also thank the entire organizing committee for working in coherence, leading into success completion of the FDP. I extend our sincere gratitude to our distinguished speakers for gracing the FDP with their presence. Dr. Shivaji Pawar, Professor, Director, Siahgad Institute, Solapur. Dr. Vidyarani Shirsagar, Associate Professor, Dean R&D, FabTech Technical Campus, Sangola. Dr. Sheshnath Bhosle, Professor, Central University of Karnataka. Ms. Kalyani Ahir, COE, Sinolet Innovation, Pune. Dr. Vijay Kumar Shivpuje, Patlex Business Solution, Mumbai. Dr. Padmakar Kelkar, CEO, Bright Star Electronics, Pune. Dr. Debanjan Chakraborty, Research Engineer, Senior Postdoctor and Fellow, Institute of Porous Material, Paris. Dr. Parsharam Shirge, Professor, Department of Metallurgical Engineering, Material Science, IIT Indore. Dr. Sidramappa Dharne, Patentee, Self-Employed, India. Dr. Anuja Yadav, JSPS Fellow, Japan University of Tsukuba, Japan. Dr. Vivek Bagchi, Associate Professor, Scientist E, Energy and Environmental Research Laboratory, Institute of Nanoscience and Technology. Dr. Suhit Gilda, Managing Director at Dr. Gilda's Nutrition, Satara. We deeply appreciate them sharing their valuable time, insights, and expertise on the patent landscape approach to science and technology correlations. Finally, I thank all the participants from different states of the India and overseas from Baghdad University, Iraq, for accepting our invitation, showing interest in this FDP, and actively attending all the sessions. Thank you all. With the permission
Thank
of
you.
Chair,
Yes.
I declare the faculty development program is concluded. Over to Sir.
Thank you, ma'am, for your kind words and for expressing gratitude to everyone who contributed to the success of this program. Before we officially close, let us take a virtual group photo to capture the memories of this wonderful event. I kindly request everyone to turn on your cameras. Please adjust your position so that you are absolutely visible. So I request everyone to please turn on your camera. Let's take this moment and capture this wonderful moment. I request all the participants to please turn on your camera. We are going to take the group of photos and we are going to capture the memories of this very wonderful event. So, Kari sir?
Yes, sir. We took so many photos of all the participants.
Yeah. Then from your end?
Yes, sir.
Okay. So thank you, everyone. I'm sure these photos will serve as a cherished memory of this impact-filled program.
Thank you, sir.
So take care, stay safe, and keep innovating.
Sir,
Have a
there
great...
is one announcement.
Thank you, sir.
Yes, ma'am. Yes, ma'am.
So participant has to fill the feedback through ATAL portal. This is the first thing. And second thing is that once you fill the feedback, the test will be resumed. You are supposed to give the test up to tomorrow. For any difficulty, you can contact me, please.
Ma'am, is there any specific time for
tomorrow? Up to what time, ma'am?
Tomorrow we will conduct for whole day. Up to 12 o'clock, midnight.
Ma'am?
Hello.
Hello?
Yes.
Yes, sir.
Madam, the test is not visible on the ATAL portal.
Yes, it will be visible after 1 hour, sir.
Hello. Okay. Thank you. Hello.
Yes, sir.
Yes.
Ma'am, I have filled feedback, but yet I have not given a test. So shall I give it later? That means you have told that up to tomorrow you can give the test. So shall I do that?
Dr. Vagesha, sir, na? Yes,
No,
the
madam.
timing. Okay.
Hello, madam.
Yes,
madam.
sir.
Madam, see, the whole FDP's feedback, isn't it?
Whole FDP's feedback you have to fill through ATAL portal through your login itself today only, sir.
Okay. Madam, see, 1 or 2 attendances, it is not there, ma'am, actually.
So we will see for this attendance issue. You can contact to me personally. We will cross check with Zoom presenting. We will mark it.
Okay.
Yes.
Ma'am?
Yes, sir.
Pritam Sahu here from Jabalpur. We have to access the test on the ATAL platform only.
Yes, ATAL portal through.
we have to log in. Then we'll be getting link over there.
Yes, you have one tab there for test
Okay.
and feedback also, sir.
Okay. Feedback I am filling, ma'am. Okay. Thanks.
It's compulsory.
Okay. Thank you, ma'am.
Hello.
Ha.
Good evening, ma'am.
Good evening, sir.
What is the criteria